Sorry, I didn't know we weren't allowed to. Of traveling as much as before. Yeah. Yeah.
Honored guests, ladies and gentlemen, it's my pleasure to welcome you to the Royal Swedish Academy of Engineering and Sciences and this year's Science and Society Forum. My name is Johan Weigelt. I'm the Secretary to the Academy and also the Executive Vice President of IVA. The topic this year is additive manufacturing or 3D printing, and we're asking the question, beyond the tipping point, where are we? And we're very happy to have secured a very interesting program in collaboration with one of the speakers, but also mostly thanks to the organizing committee comprising Ulf Södergren and Monica Belgran of Division 1 of IVA. We have a number of lectures in front of us and also panel discussion, and I would like to invite you all to ask questions during the day. And with that, I will hand over to our moderator, Ann-Louise Johansson. She's a member of Division 7, totally interdisciplinary and basic engineering sciences. Forgive me. The floor is yours, Ann-Louise.
Thank you, Johan. So my name is Ann-Louise Johansson, and I'm very pleased that I today can present a list of very distinguished speakers here. And we will talk about 3D printing, and I'm looking forward to a very exciting afternoon. So we will hear about the impact it already has had and what we expect and potentially will see in the future. And as Johan said, the question for the day is, are we beyond the tipping point? But we will not have only just distinguished speakers. The same goes for the audience. You're very welcome. I'm happy to see so many of you here this afternoon. And I hope that you will contribute to the discussion and to the topic. And I invite you as well to ask questions or add comments to the discussion. And as usual, we follow the normal procedure. You have the microphones between your chairs. Use them because we are streaming. And then the second thing, of course, is let us know your name and where you come from before you ask your question or add your comment. So then I would like to invite or welcome our first speaker, Olof Digel. And do you want to stand here or there?
I'll move around.
Yes, you move around. So Olof is Professor of Product Development at Lund University, and he will talk about printing the future.
Thank you very much. Thank you. Good afternoon all. My name is Olof Digel, and it really is a pleasure to be here. The mic's on in theory.
It is on.
It's always the technology that's fun. Testing.
Just
1,
a
2,
moment.
3.
Just a moment.
There we go. Now we have sound. Let's start again. Good afternoon, everyone. My name is Olof Digel. I'm from Lund University, but really from New Zealand most of my life. I've been in Sweden a year and a half, and it's great to be here. I'm now Scandinavian officially. My job over the next 15 or 20 minutes is to basically tell you a little bit about what 3D printing is, and I guess what its advantages are over conventional manufacturing. And then Phil will tell you a little bit more about the strategic side and how it's being used around the world. Ian will tell us a little bit more about design for additive manufacturing, and Bill will tell us a little bit about some of the intellectual property implications of 3D printing or additive manufacturing. But to get you guys started, once we have the technology up and running. So 3D printing, it's been around for, 1989, 1990, so close to 25 years. And it encompasses a whole set of technologies that really, in a way, allow us to make things in the easiest possible way. So what distinguishes 3D printing from conventional manufacturing is it's essentially a layer upon layer manufacturing process. So whereas conventional manufacturing, if you wanted to make pretty much anything, so if I wanted to make a bust of my head, for example, I would start with a block of marble, and 1,000 years ago I would take a chisel and a hammer and I would cut away all the material to make a bust of my head. So that's why it's called subtractive manufacturing. We're removing material from a block to start off with. And still today, 99% of things are manufactured in a subtractive way. Either directly, where we start with a block of aluminium, put it on a CNC mill or a lathe, and we machine away, we cut away most of the material until the part is ready to go. No, sorry. Not quite, we're nearly there. In contrast, subtractive manufacturing, we're starting with a digital file of, in this case, a bust of my head as a CAD file. We send it to the 3D printer. The 3D printer slices it up into very thin slices and then prints one slice on top of the next, and layer by layer by layer, it's adding material until the file is made. So the technical term is additive manufacturing as opposed to subtractive manufacturing. Most people call it 3D printing. I use the two interchangeably. But you think today still most things are made subtractively, either directly or indirectly, where you might machine a mold and inject plastic into it to make plastic components or cast aluminium components. So as I said, it's been around forever and ever and ever. But 3D printing, what's interesting is over the last 5 years, it's gone beyond prototyping. For most of the last 25 years, it was used pretty much exclusively as a prototyping technology. But over the last 5 years, it started to advance. So for those of you who don't get that layer upon layer process yet, this really shows it perfectly. This is a little sphinx I have in my office made out of layers of cut plywood. But that is additive manufacturing. And even older, anybody who makes clay pots. You take strings of clay, you build it up layer by layer by layer. The principle is the same. Where additive manufacturing today differs is how they print these different materials, I suppose. So very broadly, to categorize them into 3 different forms of additive manufacturing, the first would be solid-based materials. So typically, we're talking about an extrusion process. So think of it as a hot glue gun, where you take each slice of your model and with a hot glue gun, you trace out each slice of the model and build it up layer by layer by layer. So this is probably one of the most well-known ones because over the last 5 years, we've seen the maker movement, so the desktop low-cost 3D printers, when the patents expired, springing up all over the world. So most commonly, plastic is the most common material for fused deposition modeling, but also things like food products, chocolate, anything you can extrude and squeeze out of a nozzle, you can print using this technology. Liquid-based, liquid photopolymer resin, so it's a plastic liquid resin, spread out a layer, and a UV laser scans it. Wherever the UV hits, it hardens the resin, or you inkjet print the resin and UV hardens it. So that's a little example of a UV hardened component. And then finally, powder-based, where you put powdered material and a laser or an electron beam is used to melt the powder where you need to, spread another layer of powder on top, and layer by layer by layer, you build it up. This one's interesting because it allows you to do plastic materials, metals, a variety of metals, and so on. So one of the take-home messages I guess I've got for you today is that 3D printing, it's never going to replace conventional manufacturing. It's a complementary technology that has certain advantages. And there's a lot of panic around the world saying, 3D printing is going to take over, manufacturing as we know it will disappear. Not the case. That will never happen. Additive manufacturing is something that's got certain advantages, and if you use it for the right reasons, it gives you enormous advantages over conventional manufacturing. If you don't use it for the right reasons, it just costs a lot of money. So you've got to use it for the right reasons. So here's some of those reasons, and the best known one is complexity for free. So the more complex something is, the better suited to additive manufacturing it is. So this is a really good example of complexity for free. It's American Standard, and again, how does the water get from here up to here, or even worse on this one here? And that's because with additive manufacturing, you can make these incredibly complex channels going through the inside of the structure that you couldn't make any other way. So this is a really beautiful example of complexity for free. Now, the catch is you need 120,000 crowns if you want a set of these for your kitchen. They are expensive. They're about $12,000 for a set. So today, it's still high-value, low-volume product. But this is a good example of complexity for free on the aesthetic side. On the engineering side, it gets more interesting. It's called topology optimization. So it's removing as much material from a part as possible. So this is my little titanium 3D printed bottle opener, sort of ultimate accessory every person should have. But we use mathematics to remove as much material as possible while maintaining the mechanical properties of the part. So in this case, this bottle opener is rated at 300 kilos. But just to contrast material use, if you were going to make this the conventional way, you would start with a block of material. In aluminium, for example, you'd start with a billet that weighs maybe 10 grams. You would put it on your CNC machine. You'd machine away as much material as possible. You'd then end up with a product that weighs around 4 grams. You might be able to squeeze off a little bit through the middle there, maybe. Contrast that with the optimized one, down to under a gram. Now, this is an extreme case. This is a 90% weight saving. That is, a dream world. In reality, 30% to 60% weight reductions are relatively easy to achieve. Now you think about that for aeronautics, light weighting. So any product that benefits from losing weight, it is incredible advantage. You know, every kilo you save on an airplane is hundreds of thousands of dollars in fuel a year you save. So that is complexity for free. The next big advantage it gives you is what we call mass customization. Being able to mass manufacture products, but every product is custom made for you, the user. And probably one of the best known areas it's used in is medical, of course. But hearing aid, I think it's about 96% of inner ear hearing aids are 3D printed today. Most of us don't know that they're 3D printed. We probably don't care that they're 3D printed. We just care that they fit us perfectly. And they put some silicon in your ear, pull it out, laser scan it, Materialize, one of the big software companies, has written software that's specialized to remove the material from the inside, put the screw bosses in. So medical, because anything that's custom fit to our body is an advantage, is a perfect area of application for additive manufacturing. And we're seeing it happen in dental, hip replacements, vertebra replacements, and so on. So again, this is mass customization on the medical side. On the fun side, of course, printing people. So scanning yourself, and this is something we did at Kulturnatten about a month ago, where in 6 hours we scanned about 140 kids coming through. We had a little 3D printing stand. We scanned them, we printed them all out, and then gave them all their little mini-me's of themselves. But 3D scanning technology, it's still far from perfect, particularly when you talk about engineering, but for this sort of fun application. So this full body scan of myself took 7 seconds. This was at Inside 3D Printing in Berlin. You stand in a booth, the scanner spins around you, and in about 7 to 10 seconds, you've got a full color body scan that you can print out. You can go to Disneyland with your kids, scan their face, and print out a Cinderella doll with your child's own face on it. Interesting applications. So that mass customization, I predict in the next 5 years, we're going to see more and more. There's already 4 companies I know of that are doing shoe inserts, where they'll either scan or even from an iPhone picture of the bottom of your foot, will print you out shoe inserts that fit you perfectly. Headphones, various other areas like that. The next big advantage is part consolidation. And really, this is part of complexity for free. And what we talk about here is a conventional product would have been made out of many hundreds of simple parts. You can now consolidate those many simple parts into 1 or 2 much more complex parts. And this is a really nice example from NASA, where they took a rocket engine and went from 115 down to 2 parts. So here are the 2 parts there. Now you think, assembly becomes easier. Reliability becomes better because there's less parts to break or fall off. So part consolidation is a massive advantage of additive manufacturing. So those 3, complexity for free, mass customization, part consolidation, are what I would call the engineering advantages of additive manufacturing. Now we move on to the slightly softer side of things, being able to try ideas out at no risk. And to me, this is one of the biggest ones for countries like Sweden to really benefit from additive manufacturing. So this was actually one of my students in New Zealand, my previous university. And she's a cyclist, so she goes around the world with Red Bull and does crazy things on mountain bikes for Red Bull, the bicycling team. And she has a problem. She travels with a bike around the world. She's got this big cardboard box, and she has to carry it around the airport, which is never easy. So as a third-year design project, she said, I have an idea. I'll make a little set of wheels that I can clip onto any box and make it easier to travel around with my big box. So she printed them out, laser sintered in this case with the powder technology, started using them. Other athletes on the team saw this and that's cool. Can we buy some? So she scratched her head and said, what did I do now? And said, okay, I'll sell you one. And she sold one. She sold another one. Now, I wouldn't call this a business. It's not even a micro business at best. But when I left New Zealand, she sold about 70 or 80 pairs. Now she can say, this is high value. I can actually keep making them through additive manufacturing. Or there's a big market for this. I can actually injection mold them and make them in mass quantities. The point is, she didn't have to mortgage her house to find out whether this was a good idea or not. And that's the problem. If we have ideas, it's very expensive to test those ideas to see if they're any good or not. So now my own story on this respect. So in 2011, The Economist did a story on, it was called, I think, Print Me a Stradivarius. And they took the CAD files off a Stradivarius, CAD'd them up, printed them out, and there's videos, and the violin sounds good. They printed out a violin. And in my younger days, I used to play in a lot of rock bands, and I thought, that's amazing. And I've been watching 3D printing getting better and better over the years. So I said, I wonder if I can make an electric guitar. So I said, yeah, let's give it a try. I had a small machine in New Zealand, so I designed my first one, printed it out, and was amazed by how well it worked. It wasn't, it was way beyond a prototype. This was actually a usable, playable guitar. And I started a blog about it, and musicians said, that's incredible, can we buy some? So same problem Jenna had, and I said, ooh, what do I do now? And I said, all right, I sold one, and I sold another, and I'm working on the 53rd one now. It's actually the 63rd guitar, but 10 of them are in my collection. So I now produce a range of 3D printed electric guitars. I've got about a dozen or so in the range. My first one was actually a spider version of the pink one you see up there. It was a heavy metal spider version. And the reason it's that shape is not because it's a sexy shape for a guitar. That's the biggest I could fit in the printer I had in New Zealand. Then I started designing some of the other ones. And just to show you what you can do, so this is one of them called the Steampunk, the one you see on the bottom right there. All the gears, the pistons, all move. Now what you've got to consider, and this hurts the brain a little bit, the body is all printed as a single piece, assembled, ready to go. So with all the gears, with all the pistons printed inside the body. So that tells you a little bit more about that complexity for free. And mass customization, because every guitar I make is made specifically for the musician. The New York guitar, the Americana on the side, there's got all of New York City inside the guitar. But this one's the only one that's got a little King Kong on the Empire State Building. And that's because every single one can be different and it doesn't cost any more. Now, the guitars, I think, are pretty cool, if I may say so myself. But what's really cool here is I didn't have to mortgage my house to start a new business. And that's what's important, is being able to go to business with a good idea without having to spend a whole big amount of money for it. So now we've got even software. So this is about starting business, and I think there's huge opportunities for high-value, low-volume products in Sweden. But medical products, for example, are always a good customer for this. Now we go on to the much softer side, which is encouraging creativity. And the example I've got here is actually a very strange one that I did over this summer. We did 3D printed guitars, so it made sense to do a 3D printed band. So we did drum kit, keyboard, and a saxophone as well. And on the news last week, somebody in Taiwan has just printed a metal saxophone. So interesting. This one's a bit hard to see, a bit hard to understand. This is a fundamental design flaw with the iPad, which is surprising considering it's an Apple product. The speaker on the iPad is on the back, which means all the treble, all the high-frequency sounds travel the wrong way. And to make it worse, of course, when I'm lying in bed watching my TV series and it's pointing towards my wife, she gets angry at me because she's getting all the sound that I should be getting. So a very simple way of solving the problem. You put your hand over the speaker and suddenly you get crystal clear sound because all the sound bounces back. So I went through 1 or 2 nights with a little 3M post-it note over here bent to try to direct the sound towards myself. And I said, okay, there's a problem here. So I printed out a little iPhone acoustic speaker, which is just a little 3D printed gadget. You slip it onto your iPhone and you now got perfect crystal clear sound anytime you want it. And the problem, this is what is so cool about 3D printing, is you find a problem, you play around a bit, you do a few very quick iterations, and that's another beauty from a manufacturing point of view. You can do 1 iteration every 6 hours or every day. Try, solve the problem. Now, I can't watch my iPad without it because I've gotten so accustomed to it. So to me, this is one of the powerful things of 3D printing, is it removes the barrier of manufacturing that often prevents us from being creative. Another really, really interesting example of creative thinking, an American eagle that lost its beak. So it was an eagle, lost its beak. Somebody decided, I know, let's print him out a new one. So they catted it up, printed it out, again using laser sintering, glued it on. Literally, they glued it onto the eagle using epoxy resin, saved the eagle's life. Now that's a really nice example of creative thinking. And the point here is anybody could have done this the old-fashioned way. They could have carved it out of any material, done it on a CNC machine, but it's too hard, so we don't. And that's what makes 3D printing powerful, because it removes that barrier of making stuff. It means we can make stuff very, very easily and test out ideas. And the last one before we look at on-demand manufacturing, and this is what I call open source innovation. So it was actually started by a South African called Richard Van Ass, who lost 2 fingers in a carpentry accident. So he teamed up with an American and they designed him a very low-cost 3D printed prosthetic to replace those 2 fingers. From there, that grew into a project called RoboHand, which was low-cost prosthetics for developing countries, which then is now become enabling the future. So it's a website you can log on to, you can download prosthetic hand designs, print them for yourself, give them to people with problems, you can modify them, and then once you've got a prosthetic that works, you upload it and share it with the rest of the world. So this is one of the best examples of social engineering, I guess, where engineering is helping society in new ways. But what's really interesting here is what I think of as open source innovation, where instead of each one of us individually trying to solve problems, we give them to the world and get the world to help us solve them. And we're starting a little bit to see big corporations starting to get on that, where instead of trying to do all the R&D and all the development themselves, they share their problem with the world and try to get the rest of the world to help them with it. So interesting area, and it's going to be interesting to see how this grows in the future. And the final advantage, on-demand manufacturing. And what we're talking about here is instead of sending all our products to, say, China to manufacture, then shipping them around the world, we make them where we need them, when we need them. And the example here is before the Industrial Revolution, we were the supply chain. If I needed a new table, I made it myself. And the village was the market. I sold it to the other villagers. The villager on the other side of the hill was too far. Contrast that to today. I want my table. Being in Sweden, I'll drive to IKEA and I'll buy my table, who get it shipped in from a warehouse somewhere else in Sweden, shipped in from a factory in Guangzhou, who come, and you can see the supply chain is absolutely enormous. And typically, only about 10% of the cost of the product is the real cost of the product. The rest of the cost is the supply chain. Not just the transport, but each one of these middlemen takes a 5%, 10%, 20% cut to make their money. So thoughts are that the day after, tomorrow, we're going to go back to somewhat more like the Industrial Revolution, where we'll have, in Stockholm, there'll be some kind of, I've called it a fab lab, it'll be some kind of a factory where I'll go with my memory stick, with my table design that I've designed myself or downloaded off the internet or bought from a design company, and I'll go to this mini factory and say, make me a table. I'll go have a cup of coffee, come back an hour later, and the table will be made. Now, don't misunderstand. You cannot print a table today in an hour. Well, you probably cannot. Even printing a table today would be really pushing the limits of size and strength. But in 5 years and 10 years, you certainly will be able to. And you start to say, then do we start to reshore a lot of the manufacturing that's moved offshore and bring it back to Sweden by using these types of technologies to help us? And this is not just 3D printing, but all advanced manufacturing technologies. Some people are predicting the day after tomorrow, we're all going to have 3D printers at home. And when we need a new table, we'll download our designs, redesign, and print it at home. I don't think that's realistic. I don't think that will ever happen. I do believe very strongly within the next 3 to 5 years, we will all have 3D printers at home. But they will be aimed specifically at hobbies and toys. And we will use them to make accessories for our Barbie doll or whatever it is, whatever hobby we're into. So hopefully I've been able to give you just a very, very quick overview of what 3D printing is. And it is, as I said, it's a range of technologies. It's not a single technology. It's a whole range of automated manufacturing technologies using different material and different processes, but always in a layer upon layer process to manufacture parts. And I've hopefully given you a very quick overview of some of the advantages, and there are others, but these are the main ones that make 3D printing worth seriously looking into, seriously putting some time and effort into to see, are they applicable to our particular scenario and our particular context. So with that, I'll thank you and hand over to the next person. Thank you very much. Thank you.
Before you leave, we'll take some questions.
Yep, absolutely.
So please, do you have any questions? Please use the microphone. Whoops. And say your name. Yeah.
Yes. There may be a button on there you've got to press.
Okay, now you are all forced to hear me. Those who do not know me, my name is Claes Beve. I have been working in additive manufacturing for 18 years plus. I had my dissertation in 2004 and has recently returned to Sweden after a forced exile of 10 years to work for Sandvik AM Center. Thank you for the presentation. You are, as always, very energetic and enthusiastic, but you focus on geometries, the freedom of geometries and the variation of geometry. Really, a function of a part is not only geometry, it's material properties and integrity and the whole process chain. And that's a lot more, and that's a lot more challenging.
Yeah.
And I know you know that, but I want to bring the message to the people here too, that it's not necessarily that easy, not if you want a demanding part, not a fully functional part, and in particular not for metals or ceramics.
I think Klaus is absolutely right. So material characterization and part certification and qualification is absolutely critical. And I was talking to Bill earlier, he's been talking to the FAA for parts that fly. And there are hundreds of parts today that are flying on airplanes, but none of them are critical parts, because today it's very hard to certify them to guarantee the quality of them. Actually,
there are a couple.
Yeah.
There is a bracket for Airbus, and there is a repair part for Pratt & Whitney seal in the engine, which are flying, which are used and flying. They are critical.
And we know that GE is working on.
They are working on it, and they will deliver about 20,000 annually in the next couple of years. So it's definitely for real. But there are. It won't happen overnight. It's quite challenging.
Yeah.
And there's a lot of work to do for researchers.
Yeah. It's a huge amount of work to do for researchers, a huge amount of work to do for industry, a huge amount of work to do for lawyers. Bill will tell us more about that later. But the legal side, the certification side, the intellectual property side, we're only just starting to scratch the surface today of what we need to do. And hopefully we don't get frightened by how much work there still is to do, because it is exciting work, I think.
And it will be worth it.
Yeah.
Yes, another question here. You have the microphone just next to you, between the chairs.
Name is Antti Arias from Finland. You said I might have a printer like that in 5 years' time or slightly longer. What kind of a home computer would I need to run the printer?
The computer itself, I guess, is the easy side. The technical side is the easy. To me, the challenge is not the computer or even the printer. To me, the challenge is the software. How you design parts or download parts and modify them. And I personally think the CAD industry, the engineering design software industry, has a long way to go to make software that is much more usable, much more user-friendly. And I think the gaming industry is way ahead of the engineering industry. So to answer the question, I think the computer will be a standard home PC. And even today, you can already do that. The challenge will be, how do you design what you want for your purpose? And I think Ian is going to tell us a little bit more about this co-design and software that helps people to design things in the way they want, in an intuitive way.
So we have another question there.
Okay, hi, I'm John Barras, University of Maryland and KTH. So I work a lot in model-based systems engineering. We had a workshop here in Sweden back in May. So how far away are we from actually doing design in terms of requirements, material properties, structure, different materials? So before I go on the printer, I've done everything by computer like we have done in 777, and then I do it. 5 years, 10 years, 2 years?
Well, we're starting to see some of it now. So, for example, the topology optimization software, some of the new packages like Inspire, for example, they integrate analysis software, so serious finite element analysis software with the design software. Physics is still early days. And again, I hate to point at gaming, but I have a game on my computer called Spore Creature Creator where you design dinosaurs. And you've got proper physics, you've got inverse kinematics all integrated into it. But the user, the child, the 5-year-old who's designing dinosaurs, has no idea that he's doing advanced physics and, well, it's multi-physics in this case. He's just playing a game. He's got no idea. And I see the same thing. So let's say you were designing a cell phone or a bracket for an airplane. A lot of the engineering data could be hidden behind. So if you're designing a cell phone, it has to contain a battery. You have to be able to reach the fingers. A lot of that could be constrained in the software, but then you could still give the freedom of design to the user.
Can you take that question one more time and press the...
Because, as you know, the material properties we know now in the physics, they assume certain way of making it. When I start making that way, things will change.
Absolutely.
And I have to think about how I make things and what this implies about the properties. Are we getting that?
We're getting there. So one of the challenges of additive manufacturing, that layer, it's anisotropy. So the material behaves differently in the Z direction to the X and the Y, the horizontal directions. But it's getting a lot better. I mean, to give you an example, this is a 3D printed ball. 5 years ago, I wouldn't have dared to do that. And that's how the material, the properties are improving tremendously. There's two answers. So the first question is, can we get rid of the difference in the vertical direction? And the other answer is, can we analyze the difference or the effect of the weakness in the Z direction? And the answer is, everybody's working on it madly around the world. We're not quite there yet, but my prediction, 2 to 5 years to resolve probably both problems, in fact. Partly in the machines themselves, partly through post-processing.
Can I add a commercial?
Yes, absolutely.
So starting last year or two, we're trying to make a program between KTH, Technical University of Munich, and the National Technical University of Greece, where I was a student, to try to actually teach this stuff to high school students the last 2 years, and then make them actually in the summer to work in industry.
Nice.
So anybody who wants to collaborate, contact me, BARAS, and you can find me at KTH.
Thank you.
One more last question.
A very interesting presentation. Thank you very much. Quick question. Maybe aeronautics is a bit sort of a bridge too soon, but how about automotive? When would you think that we would see automotive qualified parts using additive manufacturing?
Again, it depends which kind of parts. One of the challenges I find is engineers always look at extreme components. So they look at the worst case component on a car and an airplane, and of course they always want to make it out of titanium. Whereas, my suspicion is 80% of a car is not critical, and a lot of the components today, the well-known example is Koenigsegg's turbo. There's no major, there's some stresses on it, but nothing compared to, say, the suspension parts. So for some components, even today, the technology is usable as it is. And the same with aeronautics. There are hundreds of thousands of flying parts today, but they're not mostly the critical parts, the vital parts that if the part fails, the airplane goes down.
I was just thinking, when will you think that we will be able to see 85 kind of qualified parts using this sort of technology?
The next, certainly 3 to 5 years. I think, GE as an example is one of the people that are really pushing that area, but even companies in Sweden are starting to look at that.
Thank you, Olaf.
Thank you.
Then I would like to, and a handful up. I would like to present our next speaker, Phil Reeves.
Okay.
And Phil is Vice President of Strategic Consulting within Stratasys in the UK. And you need a computer.
Yeah.
The computer is gone.
The computer is gone. It's a miracle.
Oh, there it is.
Hey, that's better. Okay.
And Phil will talk about how companies are using 3D printing to respond to global socio-economic megatrends. Please.
Okay, thank you. Thanks for the introduction, and thanks for the invitation. It's a great pleasure to come over. Just as way of introduction, so as I was introduced, I'm Vice President of Consulting in Stratasys. For those of you not familiar with Stratasys, we're I guess the leading 3D printing company globally. We're a $1 billion company. We have about 3,000 people developing additive manufacturing machines, materials, software. We now have, I think, 19 factories around the world making products for people, for companies. In answer to some of the questions, aerospace, yes. At the moment, we have a large program with both GE and Boeing making component parts, mainly non-structural parts. Automotive, to a lesser degree, because of the economics and the push towards higher value parts with 3D printing. And automotive is all about high volume, low value, so there's a bit of a mismatch. What I do in the company is run the consulting division. So we're all about solutions. We're all about helping companies understand how to embed this technology into their value chain, how to understand how to make a business case for using 3D printing. So, why are we all here? I guess everyone's here because they've seen all of these articles, all of this. I'm not going to call it propaganda, but I'm certainly going to call it hype. You read some of these comments about new industrial revolutions and printing Stradivariuses and inventing the future, and additive goes mainstream, and the premise is that everything is going to change in society, and there's a new industrial revolution. Yeah, and that's the message that unfortunately our industry has been pushing for maybe the last 5 to 10 years. I'm not sure it's necessarily that true. Because the reality is, as Olaf kindly pointed out, all we're talking about is making things in layers. That's it. That's the fundamental change. We used to make things by subtractive or formative or fabricating. Now we make it in layers. Is that really so profound? Is that really going to change economies and reshore manufacturing from low-wage economies? Is it that important? There's some interesting stats that go behind some of these claims. There's some quite big numbers being thrown about. People like McKinsey are saying that this will be a $200 billion industry by 2025. If you pin McKinsey down, they won't tell you how they came to that number or how they make it up. I would love it to be $200 billion of machine sales, but it isn't. It's $200 billion of product. The global aerospace industry is worth $660 billion a year. So put these things into context. Is it a big number? Is it not a big number? It's a bigger number than the number we have today. But there is growth. I think the key thing here to consider, and when you sit back and you think about this as a realist and sit in a cold room in your garden and think, well, how the heck are we going to get to $200 billion from where we are today? There's only two ways. One is doing what we do now, which is looking for what we would call low-hanging fruit, looking for a business application that fits the technology we have. Because do not illude yourself. There have been no new 3D printing technologies for 20 years. They're all fundamentally the same concept of powders and extrusion and laser beams and electron beams. And as Olaf showed us, hearing aids and dental aligners, they've all found an application. They've all found a technology that works. And then there are billions of other manufacturing applications that don't work. And that's really the second reason, because we've never made technology to fit the product. And this is my big contention between what we call rapid prototyping and additive manufacturing. My company makes rapid prototyping machines, and they are universally flexible, because today they have to make one product, and tomorrow they have to make another. Yeah? If I run a car factory, if I make aerospace ducting, or I make a certain component part in a medical device, I do that today, and I do it tomorrow, and I do it the day after and the day after. The geometry might be different, but my market is the same. The bounding box of my part is the same. But to this point in time, we've never innovated technologies to fit products and business cases. That, to some degree, is where the industry is shifting. So we as a company have said that we're making a concerted effort to become a solutions company, not someone who just sells machines. So show us what the machine needs to do. We innovate the technology for the application. That's how we get to $200 billion. But why do we need to do that? Why do we need more technologies? We've got to 2015 with machining and casting and injection molding. Why? Why do we need this new approach? And I think, this seminar was about society. So I kind of thought, well, okay, what is it? What's changing? And of course, this is nothing new. Society's been changing ever since society started. But the big mega trends that we're seeing impacting on us as individuals and consumers and patients, the societal changes, aging populations, changing birth rates, millenniumism, millennium babies. There's a huge change, a societal change. Culture and connectivity. 10 years ago, we would not have conceived the way that culture is driven by connectivity. How Twitter and Facebook and everything that connects us and drives our purchasing patterns has changed. The environment, of course, is a huge issue. And it's becoming more of an issue. I was in the States last week with a cosmetics company, and their biggest drivers for the future are actually about the impact of pollution on the skin. That's what's driving their company's roadmap. I probably shouldn't have told you that. I'm going to get sacked. And the economy, globalization. We live in this enormously globalized, changing world. I come from Great Britain. We might want to join the euro, leave the euro. Actually, what we want to do is drop the great bit, because I'm not quite sure why we have it anymore. Things have changed. The world has moved on. The economy moves around. That's what we're faced with as manufacturers. I showed you some of those covers of magazines earlier because we've been talking about industrial revolutions, and I'm not quite sure journalists really understand what the triggers were to genuine industrial revolution. If you follow some of these back, the original industrial revolution, 1760, Richard Arkwright in Cromford, harnessing the power of water to mechanize it. That was a revolution, taking human muscle power away and replacing it with the energy of another force, a motive force, and it was water. You know, the second industrial revolution we forget about was actually a materials revolution. It was about the Bessemer steel process. It was a way of consistently making good quality material that we could then, following on from one of the questions earlier, we could design around. Because until that point, we had no consistent mechanical properties. You know, and then we had this third industrial revolution, the digital and the communications revolution. And you know, those together are being cited as a third industrial revolution. Is 3D printing a fourth industrial revolution? I don't think it's impactful enough to be thought of on its own. So, just going back to the revolution, what did you achieve? You know, I was looking last night and thinking, Sweden, I don't know a great deal about Sweden. It's a lovely country, and I've spent some time with Lars in Östersund, getting very cold. But the 3-point seatbelt, that's pretty important. That's been driven by societal need enormously to reduce accidents and reduce death, and I'm sure was driven to some degree by changes in legislation. The pacemaker, again, incredible innovation. You know, that's at the cusp of materials. It's at the cusp of digital. The zipper, I didn't realize the zipper came from Sweden. It's an interesting one. Again, what was that about? How did that respond to a societal need? What was it? What was that societal need that people said, actually, I don't want to tie up pieces of lace anymore. I want to zip things up. The safety match, obvious societal need. I don't want my children setting fire to my house. Tetra Pak, that's an interesting one. There's lots of arguments about, was that environmental? Was it social? Is it better than having glass, having waxed paper? What's the driver? And then the modern ones, Spotify, Skype. You know, Spotify is really interesting, responding to a change in culture, the way that we access digital data. Skype, the way that we communicate. So I wanted to put this in here because I'm going to come on my very last slide back to where you are today according to the OECD. So, industrial revolutions. There is a fourth industrial revolution, and it was first postulated about 4 years ago by the German government. And the German government believes that we are at the cusp of a fourth industrial revolution, and it's called Industry 4.0. The idea here is that we take everything that came before, but we include the consumer and we include the connected supply chain. So we now live in a world where I have a device in my hand that fundamentally can control what happens in a factory. And what happens in a factory can control what happens in a logistics warehouse, that can fundamentally control how something comes back to me. And that's a closed-loop manufacturing cycle. And that's Industry 4.0. So the wording is a little convoluted. It's connecting the value chain, cyber-physical production systems. It's connecting the whole supply chain from designing to making to consuming. And that's where we are in society. We think 3D printing sits really quite neatly in that supply chain because it's one of the few technologies that allows us to be flexible enough to respond to the changing needs of consumers. But we need to integrate it with lots and lots of other technologies, software tools, and that's one of the things we're doing a lot of work on with people like Cisco and SAP and the robot manufacturing companies to understand how do we genuinely integrate 3D printing into a factory environment. So if you look at 4.0, we call this the Reeves continuum in our office. So whether this is true or not, I'm not sure, but we believe that there are two interplays going on here. You've got manufacturers, retailers, and brands, and you've got consumers. And at one end, you've got companies that make everything to stock and consumers who buy everything on demand. And at the other end, you have brands that make nothing and consumers who want to make everything. And every company sits along there somewhere. Maybe you're in the middle where you're a consumer who wants to personalize everything, but you accept that a manufacturing company will make it for you. Okay? And that bit in the middle is really the space for the Industrial Revolution. It's the space for companies to decide where do they want to sit. So, just going back, and Olaf sort of touched on this a little bit earlier about this use of two terms. People talk about 3D printing and they talk about additive manufacturing. And some people use it interchangeably. I don't know if I'm on a one-man crusade to try to stop that, but I think there is a difference. A fundamental difference. And that is that 3D printing is where consumers are the manufacturer, and additive manufacturing is where layer technology sits in an existing supply chain. And they are two very, very different value chains. So I want to take you through them both. And I'll start with, if we can get the tech to work, we'll start with consumer 3D printing, because we haven't talked much about this. Thing to note about consumer 3D printing, relatively new concept, about 2009, open source project, lots of open source innovation. What have we seen in consumer 3D printing? An enormous growth in technology capability. It is amazing how good people who don't work for companies are at doing innovation. Point number one. Whether it's because they're more motivated or whether they don't, I don't know. I don't know what it is. But I'll be honest, the amount of innovation that we've seen in crowdsourced, kickstarted, collaborative ventures has been absolutely astounding. If you take MakerBot as a company, they started in 2007 basically taking designs off the internet. And by 2009, they modified those designs somewhat. 2010, they were offering a kit for 3D printing. So it used to be that you went on the internet and you sourced all the component parts yourself, and then you got them from Amazon and eBay, and a week later you had this pile of bits, and then you download the design file and it tells you how to assemble it, and then you download the firmware and hopefully it all works. MakerBot said, no, I tell you what, we'll sell you all the component parts, you can build it yourself. And interestingly, they then very quickly realized people didn't want to do that. They weren't interested in building the machine, they were interested in using the machine to print objects. So they stopped selling kits and started selling machines. And then they started fielding all the queries and the questions about, well, it's not very automated and it's not very intelligent. To the point where we now have machines that are self-regulating. I'll come on to it in a minute in terms of the control systems in them. Another observation, one of the barriers that people have put up to consumer 3D printing, it will never happen, it's too expensive. I've just bought one of these. I put it through on expenses and the company got really annoyed because it's a competitor. They don't like you doing that. $349. That's less than I paid for my son's Xbox. So the idea and the argument that 3D printers are too expensive to be consumer devices is nonsensical. Come on to this. They're also intelligent. They've become Internet of Things addressable objects. So the current MakerBot has build status monitoring. It has cameras embedded in it. It has performance monitoring. It knows how much raw material's left. It sends me packet data to my phone to tell me it's finished, or do I want to start the next build, or it tells me that the material's run out, and if I want to go into the office, there's 20 hours of build time left. It also tells me there's 15 minutes of build time left, so don't bother wasting your time coming and filling me up. Industrial additive manufacturing machines don't do that, but consumer printers do. So the point I'm trying to make here is that the consumer printers are driving this industry to some degree. What we're also seeing through this Internet of Things approach is that machines are coming addressable. And again, come back to Spotify here. So I'm sure we're going to hear a little bit about this in the session on IP later, but one of the big concerns, certainly from brands, is I don't want to make my data available to somebody to print because I'll lose control of my data. And it will be put on Pirate Bay and it will be shared and everything will be out in the world. Well, actually, we don't need to think in that context. The music industry and the film industry have driven our psychology to think like that. And the reason the music industry and the film industry has had to change is because at the time we were copying files and streaming, and downloading from BitTorrents. We didn't all have broadband. We now all have broadband. We actually can download data quicker than we can use it. So all of a sudden, we don't need to download data to print it. I can stream data and print it. I never need to see the data. So I can protect the data. I'll give you the bits that you need just at the point in time when your printer's ready. And if your printer fails, well, it can tell me it's failed and it can start again. But when you've got your object that you paid for, you have your object. You don't have the data. That's a business model that's already being developed by a number of companies like Authentize and PrintShield. So we've got low-cost consumer 3D printers that are internet addressable, that we can download data and stream to them. Okay. How prevalent are these things? There's about 200,000 consumer 3D printers in the world. This is one of my favorite companies. These guys are literally just across the water in Amsterdam. 3D Hubs started 2 or 3 years ago with a vision. Their vision was to network consumer 3D printers together to make the world's biggest factory. And that's exactly what they've done. So I checked this morning, there were 23,434 printers on this network. Yeah, that's a virtual factory. I checked a bit more, and I put the postal address in for this building, and what you'll see is that Alex at the top there actually has a hub that's 1.4 miles away from here. So actually there's a 3D printing factory that I can get to now on my mobile phone to get things printed. It's 1.4 miles away. Alex will ship it to me. I can go and pick it up from his house. If I can't do the CAD, he will do the CAD because he offers modeling. And he can get it to me in 3 days. Yeah, 24,000 of those people around the world. Society is becoming the manufacturer. So how are we responding as industrialists? Some smart companies are already starting to understand this. Fairphone is a great example. So Fairphone are a company who they're challenging the kind of mindset of Apple and Samsung and saying, why do we as consumers not get true visibility of the objects we buy? Why is there a shroud of mystery around the cost and the bill of materials? Why won't Apple tell us what the chip costs or the assembly? Why are they scared and frightened to share that? So Fairphone's model is a totally different business model. It says we will tell everybody what our bill of materials is, and our R&D costs, and our assembly costs, and our profit margins. And we'll make it fair and equitable. And you can see, and if you like that concept, then you can buy our product. And if you buy a Fairphone, which will launch this year, it comes with a link to the 3D Hub's website, where you can go one step further. You can get your cases printed on 3D Hubs locally, and it will equally show you how much do 3D Hubs get. How much does the guy down the road get paid? Because these people making parts at home are getting paid. They're actually recouping the investment they made in their 3D printers. They're amortizing their investments. That's a really unique business model. You know, none of us did that with our 2D inkjet printers. So this is the way that the home industry is emerging. Of course, it does have its problems. You know, not everything is perfect. You know, I'm an engineer and a realist. Sometimes things look like that. Okay, that's what comes off consumer 3D printers. I always get the guys in the office to tell me about the build log on one of our consumer 3D printers. 63% of the builds that have started failed. Yeah? Don't talk about Six Sigma. Don't talk about 5. Don't talk about 4. You know, that's where we are with consumer 3D printing. But it will improve. It will get better. And we're already challenging this. So if consumer 3D printing is limited, then what about industrial additive manufacturing? And Olaf talked a bit about this earlier. We as a company think that there are 6 fundamental business reasons why companies should investigate using 3D printing. And if you can't match your business to one of these 6, then it isn't really applicable. There is no reason to investigate it. So it's about economic low-volume production. You know, if your business is in mass production of low-cost products, then this technology is not for you. Increased product complexity, as we've seen earlier. You know, this idea of geometric complexity for free. You know, it's a very difficult concept, this concept that we are dislocating the complexity and the price. Because in most manufacturing processes, the more complex the geometry, the more expensive. Product personalization, which we'll come on to. Product personalization is really the coupling of complex parts and low volume. You know, we're 9 billion people, we're all a different size and shape. You know, that's the net effect of low volume economic production. Part functionality, I'll give you some examples. Environment and optimizing the supply chain. You know, the companies that we work with are all striving to use 3D printing to address one or more of those different drivers. So as we've seen, this idea of low volume, you know, what do we mean? Well, we actually mean applications where we can reduce fixed assets or replace fixed assets, eliminate tooling. You know, there will always be injection mold tooling, as we've heard already, high volume mass manufacture. But what we're seeing as the cost of additive technology comes down and the productivity goes up, the number of parts we can make cost effectively before it's worth investing in tooling is going up and up and up and up. So if we went back 10 years, it might be 10 parts. 5 years, it was 100 parts. Last year, it may have been 10 parts. You know, I've seen technologies in laboratories that are 20 times faster than today's fastest 3D printing tech. all of a sudden we're starting to get down into the realms of injection molding. So that opens up huge opportunity. There are other reasons, though. Reducing capital investment and inventory. We've done some work with people on the whole innovation process and saying, if you didn't spend $1 million on invest on tooling, what would you spend the $1 million on? How do you generate wealth? By freeing up working capital. Simplifying the supply chain, as we've heard, reducing lead times. There's a huge amount of cost tied up in supply chains. Mitigating risk, speed in the innovation cycle. Design complexity. As Olaf said, it's all about making the things that we can't make traditionally. Re-entrant features, complex honeycombs, consolidating assemblies. That's a driver. Personalization. I think there are two types of personalization, and we get a little bit confused with this. And we need to start talking about them slightly differently. There are products like the Invisalign dental aligner that are personalized by the nature that they fit the consumer. Okay, but the consumers had nothing to do with their design, apart from being the thing that has been designed around. The person has been scanned. That's a type of personalization. Another type of personalization is the toys and the dolls, where I go onto the internet and I become the designer. And I'm having an input on the design process using what's in here, not what's around me in terms of my body shape. And they're two very, very different value chains for different types of companies. So we're seeing lots of things. Medical devices is very prevalent. Cultural, emotional icons and artifacts. And co-creation, which I know Ian's going to talk about later, with this idea of who is the designer anymore? Is it the guy in the office, or is it the consumer at home? Who does it? Part functionality is worth bringing up. This is something that a lot of companies are striving to exploit. This idea that with 3D printing, additive manufacturing, we can add more value than just a geometry. So a good example of this is some of the things we've seen on orthopedic implants, where if you look at the traditional supply chain for an implant and map it out from a cost engineering perspective, if you look at acetabular cups, the most expensive part of making the hip implant isn't the metal drop forging. It's not the CNC machining. It's putting the physical vapor deposition ceramic coating on the surface that the bone grows into. So actually, if I'm using 3D printing, the first thing I want to focus on is, can I get rid of the ceramic coating? So in the case of hip implants, I can, by putting a surface texture onto the 3D printed part. So all of a sudden, I've displaced a very expensive part of the supply chain. Now, you could argue I've replaced another cheap part with an expensive part. But that's the importance here of looking across the whole supply chain. The other things that we're now seeing is embedding secondary materials, secondary elements, putting electronics into parts, this idea of grading multiple materials, which I know you've been looking at for many, many years. Why do we have to think in a homogeneous material? The inside of a shaft can have a certain torsion, but the surface of a part might give us a wear resistance. We can start to think differently about materials. They don't have to necessarily be homogeneous. The life cycle, Olaf touched on this again. This is a really important driver on many, many levels. Your bottle opener is a great example, but the 90% benefit was a materials benefit. So actually we have a raw material benefit here. Are there any materials companies in the room? Because they really don't like hearing about this. Okay, we don't necessarily need as much of it anymore. And that's one of the benefits here. If we're not taking huge billets of material and then having to machine them and then downcycle them. The other thing is optimizing efficiency. This is a benefit of the design flexibility. So if you talk to GE about these engine components, the benefit to them is actually in the efficiency they get. So this component part, yes, it's made in one component. It's very, very expensive compared to an investment casting. But what it gives them is an efficient engine. 40% or 25% efficiency in the engine. They're going to pass that on to their customers, and they're going to pass it on as an increase in price. So if I'm going to save you 25% over the next 30 years on my engine, I'm going to charge you more for it. And you're going to pay for it. And I can tell you what they're charging for the engine is significantly more than the increase in the cost of the parts. So again, looking at the value add in the overall supply chain. And then the one that I love and we get very involved in the office and get very emotional about is new supply chains, whole new models. If we can displace these parts of the supply chain, can we genuinely look differently? Olaf showed a great slide, his last slide, about the change. Yeah, well, the change is happening. This is a company that we work with that uses our machines. They have a factory in the middle of Manhattan, most expensive real estate in North America. Why would you put a factory in North America in Manhattan? They've done it because actually most of their custom comes off the internet. But having a walk-in facility gives them an enormous amount of marketing capability. So what these guys do, let me explain the business case. So this is a company called Normal. And if you go on your phone and download the Normal app on an iPhone or an Android phone, you photograph your ear, put a Swedish krona next to it, okay, and send them the photograph. And they'll go online and find out what the size of a Swedish krona is. And hey presto, they've got a datum. And then from your photo, they use software to extract the geometry of your ear. And then they put that into their CAD, and that's what becomes your in-ear headphone. And what's really neat, the packaging is beautiful for this because they use the same data to print the packaging in 3D. So you get a premier product back. The quickest we've seen them do it so far is 2 hours. So if you walk in and get scanned, you can walk out 2 hours later or go and have a cup of coffee and you've got a product. That's a totally different business model. Most of their revenue comes from their internet sales through their app, but all of their production is done in Manhattan, where you can walk in, and that's where their brand is built from, the fact that it is built in a factory in Manhattan. So, we're in this position where we've got distributed manufacture. This is a demand pull business model. Yes, they had to make a capital investment, but they have very low amounts of stock. And the stock they do have is relatively low value components. We're moving towards this idea of stockless supply chains or even chainless supply chains. It's all happening today. That's the realities here. So just to summarize, 3D printing, industrial additive manufacturing, they are disrupting businesses without a shadow of a doubt, but they're enabling other opportunities and they're responding to changes in society. I think they will play a really important role in this idea of Industry 4.0, and they will have a really profound impact on individuals, whether we're consumers or patients or people within manufacturing or retail or society. This technology cuts across many, many different aspects. We did a project recently looking at the union issues of putting 3D printing into a retail environment. What happens when retail workers are told they have to become manufacturers? And that's the sorts of changes. So what does it mean for you guys? Well, sort of mid-sized country, 42nd richest based on GDP, 26th richest per capita. That's interesting. 163 billion of exports and 151 billion of imports. So you're a net exporter. So what are you going to net export that's 3D printed? Or what are you going to offset internally of that 151 billion that you import? So you're going to create wealth that way. Some interesting stats, 87 million internet users out of 10 million people, and 12 million mobile devices. So there's more than one mobile device per person in Sweden. And I've been talking about apps and integration and driving the manufacturing supply chain using mobile phones. Ooh, and you've got a very high density of uptake. Interestingly, 85% of you live in cities and urban areas already. So you can drive a manufacturing economy around urban areas just like Normal are doing in New York. High life expectancy. A lot of millennials in this country, a lot of people who already think about apps and Facebook and Twitter and changing the way that they consume. But on the downside, that's quite high unemployment, and that astonished me. But if you have an argument, take it up with the CIA, because that's where I get all my stats from. So just to conclude, where do you want to be? Where should this country sit along that continuum? Is it all about consumers making products or about industry selling 3D printed products? And with that, I'm going to finish off. If we've got any time for questions, I'll take them. If not, I'm going to be around for the rest of the day. So, okay, good.
So, any questions? Please.
Ingmar Wistrand, Swedish Patents and Registrations Office. I had a question with regards to the largest manufacturing company, the Hub. I'm not sure.
3D Hubs, yeah.
Have there been any controversies with regards to IP rights infringement of designs or?
To my knowledge, no. But it's a very valid question. At the moment, within 3D Hubs, they have a ULA that says you must not infringe IP by uploading. I don't believe they are actively monitoring. And we've looked at this with all of the online 3D printing companies. They tend to wait until there's a takedown notice. But whether somebody is uploading a file having it printed locally, going and getting it, and then that data disappearing and that file being infringed, an infringement of IP, I've not heard of any cases of that happening. But the way 3D Hubs works, you have two ULAs. You have the person uploading, and you have the person producing. Now, the person producing is the one who's told not to print things that appear to be an infringement of IP. But again, that's the grey area. What is an appearance of infringement? So, yeah, there's been some work, and we did some work a couple of years ago trying to look at whether you can analyze an STL file to work out whether it is an infringement of existing IP. But we are decades away from having that level of computer science. So it's governed by user agreements, not by science or rigor.
More questions? Yes, there. Please.
I'm Ola Landström from the Swedish National Board of Trade. I can see I have the same question as the last question, but you can look at a lot of things, not only IP rights, but also product regulations. And what if I print out Lego toys based on that? You have the IP for the Lego, but the plastics might be poisonous as well, and I give them to my kids to chew on. And you turn the product chain upside down when you turn the consumer into a manufacturer. And the liability of the good is very interesting in that instance.
Yeah, and I think the answer, and whether the lawyers or the control freaks like it or not, the answer is common sense. I think I'm a pretty good cook, and one of the metrics of being a pretty good cook is I know what is edible. Yeah, I'm in a kitchen where I have bleach, I have washing up liquid, I have window cleaner, I have really aggressive stuff that I clean my cooker with. I never put it in my food. So I think we have to take this approach of saying we have to apply sense and logic. I'm not going to print. Yes, okay. There are issues about CE marking, except in America. Okay, yeah, where you'd probably Okay, let's not go there. But no, it's a very, very valid point where yes, who is liable? I mean, that's one of the most important things here. If I upload data but the data is corrupt, or the design file was a poor design file, and then the product fails, am I liable? If someone prints it out for me using the wrong material, are they liable, or is the machine vendor liable for allowing that machine to take the wrong material? So there's lots and lots of people around the world thinking about all of these different permutations, and some are going about it in a very constrained way, and some of them are going about it, I suppose, in 3D Hubs as an example, in a very maverick, Wild West way. That's innovation. So there is no answer to the conundrum. We cannot do it, but we get nowhere.
Thank you, Phil.
Okay, no problem. Thank you.
Now we will break for coffee, 30 minutes, but you should aim to be back here 3:35. Thank you. Ursäkta mig, men du har en tråd som hänger ut här. Du får nog peta in den. Den är nog från... Nej, jag petar in den åt dig. Den ser rolig ut. Så, nu är det bättre. Ja, varsågod. Ja. So it's time to start again. Hope you had a refreshing cup of coffee and you're all set for the rest of the afternoon. So I would like to welcome our next speaker, Ian Campbell. He's a reader in computer-aided product design at Loughborough University in the UK. Welcome.
The coffee for me just wasn't a refreshment, it was an absolute chemical necessity. I was up at 3 o'clock this morning to get the plane, so I think I'm running on caffeine. It's wonderful when you come to a new place and meet new people, but even sometimes when you meet people you know before, like Olaf, you learn new things. Like I didn't know that Olaf's favourite use of 3D printing was making things for his Barbie dolls. But it's interesting what you find out about people, isn't it? I'm going to be talking about 3D printing as a driver for innovation. And myself, I'm an engineering designer who's now working in an industrial design school at Loughborough University. And so most of the perspective I have is coming from the design side more than the materials or manufacturing aspects. But where I wanted to start it, again, a bit like Phil, when he talked about some of the propaganda, some of the hype that there has been around 3D printing, maybe one thing which really kicked off 3D printing in the public eye quite large was when President Obama, I think it was in one of his State of the Union speeches, said this: 3D printing that has the potential to revolutionize the way we make almost everything. And interesting he said that. Again, whether he's right or not remains to be seen, but I think it's quite optimistic. But following on from that, we have quotations in Forbes magazine: 3D printing is about to change the world forever. Harvard Business Review: 3D printing will change the world. And even some of the companies who are making these machines see it as having a big impact on society. So for example, XFab want to unleash the inventor in all of us. And these people seem to be pointing to everybody in the world starting to make things with 3D printing. And along with Olaf, I think that's probably not realistic, or if it is realistic, it will be for little odds and ends, perhaps around the household. But certainly what I think we can say about 3D printing is that it is a great innovation in itself, and also it leads to further innovations. 3D printing certainly makes new things happen. And I'm just going to show you a few things, some of which are quite old now, others are very, very new. But I think they're examples of where 3D printing has been used to create innovative designs or innovative products. So in terms of what I call impossible shapes, we see here, this is a chap called Nick Irving. He's what you could call a digital sculptor, except although he creates the sculpture in the digital realm, he then outputs it in the physical realm using 3D printing. And he does create some amazing geometric complexity. And I think of all the complex objects I've seen made with 3D printing, these are amongst the most complex. And I say to my students, how long would it take you to CAD model that? And I know the software he uses, or I guess the software he uses, but even using that software, there's many, many hours, if not days, or perhaps even weeks of work, but such is the life of a sculptor. Then we can see some other things moving closer to product design. This is we could call fashion design. And this is a Dutch designer, Iris van Herpen. She's been creating designs for, could call them dresses, except when they were first made, they were rigid. And I'm not sure that really qualifies for a dress. It sounds more like a straitjacket to me. I wouldn't like to be walking around like this all day long. But now they're even making them in flexible materials. And once again, the complexity is quite extreme. But interesting to see that some of the designs are going back to how we would fold material when we had time to do that. Then more recently, thinking about some different materials that are being used with 3D printing. This is something that came out of MIT. And I was asked to print 3D glass maybe 15, 20 years ago. I came to the conclusion then that it was next to impossible. These guys managed to do it by having an oven, a furnace on top of their 3D printing machine, holding the glass at over 1000 degrees C and then extruding it out. At the moment, they're really just creating objects of beauty, but their intention is to start creating functional products as well. So this is innovation, I guess, in materials, certainly for 3D printing. And then some people think that 3D printing is a way we can create interesting food. Now, this is just a bit of fun here, but actually NASA are interested in this to try and make meals on the International Space Station more interesting. Okay, so it does have some practical applications as well as a bit of fun. I think what you could do is actually create something that's got the sort of vitamins of broccoli, but the taste of chocolate, and then we can get our children to eat broccoli, because I don't know about your children, but mine find it very, very difficult, or perhaps even spinach would be even worse. So anyway, 3D printing of food, quite an innovation. I'm not saying it's very healthy food, but you could actually design it to be healthy food as well. Then very recently as well, the FDA in the Federal Drug Administration in the United States has just approved this. It's the 3D printing of personalized pills. So the medication is tailored to an individual patient. Now, that can be done in other ways, but this is a quicker way of doing it. I guess the printing material might be something similar to sugar or flour or something inert, but then you print the chemical into it as well. What you can also do is, if you want to have different chemicals released at different times, you can embed the chemical at different depths in the pill as well. So again, something interesting, something innovative being done with 3D printing. Then I know a lot of us are now, I think it's interesting that Phil made a distinction between 3D printing and additive manufacturing. And I can see how there has been a sort of dichotomy in the marketplace. And if you look at something like this, and I think we probably would call this additive manufacturing. This is an engineering component. It's a Formula One engine cylinder head. I used to design cylinder heads, and I could only dream of ever creating something this complex. I mean, the external geometry is incredibly complex and very organic, but the internal structure has been made to save weight. And if you wanted to, you could also put that inside the water cooling passages as well to create more turbulent flow. So one of the reasons Phil talked about using additive manufacturing is to optimize functionality. Well, you could certainly do that with these cylinder heads, but you're also lightweighting. You're trying to get the weight down as well. And once again, this is an example of the complexity that we can create with 3D printing. So we can look at all those things as being innovative, either the materials being used in a different way, or the products being created in a different way, or even maybe just the shapes themselves are innovative. But I think if we want to look at perhaps a deeper level, I think that the real innovation that 3D printing can bring is when it changes the way we think about designing and making, and perhaps how we even do business. And so what I want to do is kind of take you through a little bit of a tour of how I think the way we do business is changing, has changed, might change in the future. And so my starting point, so I'm calling it evolution of business models. It's more consumer, designer, maker models, because I'm not really looking very much at things like the supply chain or finance or so on. But if we start with what we could call a fairly conventional route to market, we might have started off with using some market research to go out and hopefully find out what our customers want. Designers then try to take that and change it into a product design specification, and then a detailed design which is made and sold back to hopefully lots of consumers. Lots of people will want to buy your product because you have investigated the market correctly. One problem can be that the market research is done by market researchers who perhaps are looking for different things than designers might look for. And if market research doesn't ask the right questions, then you end up with the wrong product. And I don't know how many people in Sweden will recognize this product. It was actually a product called the Sinclair C5. I think it was developed in the 1980s in the UK. And Sir Clive Sinclair, who had made his money making home computers, decided he was going to make a vehicle that was going to revolutionize the way we transport ourselves around in the UK. And they asked people of different ages, what would you want from a vehicle? And they answered all the questions. And this is what they ended up with. Now, how many of you would... It had a top speed of, what's 15 miles per hour, about 25 kilometers per hour? How many of you would want to drive through traffic in that? Kind of a show of hands. Okay? So it failed completely. Even though the designers did exactly what they were asked to do, but the marketing information had been either poorly gathered or poorly interpreted. So one way of getting around that is to try and bring the designers closer to the actual consumers or customers. And one way of doing that is to use a focus group. There are other ways. If you're not sure what a focus group is, it's where we get some, we could perhaps call them typical consumers. Sometimes they're lead consumers, early adopters. And we get them into a room. We feed them full of cookies and lots of sweet drinks, and not to give them energy, so they think new thoughts. But we might also show them some plans for our product and ask them what they think about that. And what we're trying to do is to identify any failures in the concepts before we go any further into detailed design. So it's a way of trying to bring the designer closer to the consumer. And many companies have found this to work quite well. So that's evolving a little bit. But if you want to take that to the extreme, and we've seen some examples of this already, it's where we stop trying to design for the whole market and we say, well, let's just design for individual consumers. So rather than trying to guess what the whole marketplace wants or work it out, we say, well, we'll ask individual consumers what do they want, and we'll make that for them. And so what we're really doing is saying we're not going to be aiming for a large market. We're going to be aiming for personalization. And there are some good examples of that working. One of my favorites is this one. It was originally a company called Bespoke Innovations. I think they became part of the 3D Systems empire. But what they're doing here is tailoring the design of prosthetics to specific individuals' needs. And so, for example, if you were ex-military, you might like something along the stealth line. Or if you have got a particular interest in carpentry or whatever, or there's another photograph of somebody who drives a Harley Davidson. He wanted a chrome-plated prosthetic, and somebody else, a lady, actually wanted her prosthetic to look like fishnet stockings. So you can have any design you like tailored to the individual consumer. And we could call that bespoke or tailored manufacturing. So that's one way we can go. Another way, and this is part of what we were seeing in some of the so-called maker bots and so on, the machines, where we're actually saying that people are going to become their own manufacturers. So we have the individual consumer maybe requesting some information from a designer, or they could do this. They could actually try to do the design and making themselves using 3D printing. I should have said actually with the previous examples of bespoke prosthetics that they were made with 3D printing machines. So here, once again, we're not concerned about the large scale market. We're looking at individual consumers, but this time they are DIY manufacturing, sometimes called the maker community, where they will be happy to do a little bit of design themselves, and either they'll have their own machine for making it, or they might take it to a fabrication shop or similar. I have a difficulty with this as well, in that we've done a lot of sort of research with ordinary consumers, and the number of consumers who want to do design and going on beyond that who are capable of doing design is actually very limited. Especially if you ask them to design something from nothing. We call it the kind of blank sheet syndrome. You give them a blank sheet and say, show me what you want or design anything you want to make, and most people just don't have a clue how to approach that. You do get some people who will do it and are very good at doing it, but they are maybe 10 or 20% of the population. So this does work, but not for everyone. But one way they can do it is to make use of what we're calling easy CAD systems. And this is an example. It's a CAD system called 123D. It's made by Autodesk or sold by Autodesk. It's a very easy to use CAD system. And most people, certainly people who aren't professional designers, can jump onto this CAD system if they're computer literate and come up with some sometimes quite simple designs, sometimes more complex. And the whole idea being that they would then ask for this design, either make it themselves or ask for it to be made, perhaps by sending the design to a company like Shapeways. And here's some examples of products that have been designed and manufactured in a sort of DIY manufacturing environment. And certainly you can get some quite interesting things coming out of this. But we always see this as being quite a specialist thing. The sort of person who in the past would have been happy to go down their garage and maybe use some different tools to make something for their house. Okay, that sort of DIY mentality. Some people love to do that. Some people have got no intention of ever doing that. But these tools can take that into the digital realm, both on the design side and on the manufacturing side. And then something which is similar but works in a different way is where we actually allow the consumer to be the designer but never to consider manufacturing. So it is quite a similar thing where they will do the design work but will allow the 3D printing to be done by someone else. But the difference can be that if the design is something which they not just they like, but other people like, then that can be uploaded and made available, as we'll shortly see. And the sort of thing that can happen is you can create your own personalized 3D printed jewelry. And if anybody hasn't done this sort of thing before, I'd recommend that you go to the website for these people, Nervous System. They don't just do jewelry, they now do a range of consumer products. And the interesting thing, and this is where they've been very clever, is that they don't give you a blank sheet to start with. They give you maybe a fairly simple design as a starting point. And most people, given that, are able to tweak it and change it to turn it into something unique. And that was a very clever thing that they discovered. Don't expect people to design from nothing. Give them a starting point and allow them to make some changes. And that's a philosophy that we've taken on board at Loughborough as well. But the clever bit here is the software which runs over the internet and allows you, typically using slider bars, to change the diameter, the number of holes, the thickness of the ribs and so on. And you can, from the same basic design, so the same CAD model starting point, you can create a whole range of different products. And the intention is that you will create one that will be unique to yourself. Now that uniqueness can't be guaranteed, but that's the idea. Now if we go beyond that, I've called this crowdsourcing. It's maybe not the best term to use, but again, it's looking at individual consumers becoming designers, okay? But instead of just one consumer working on their own, they become part of a community. And I know Phil showed us a good example of this as well. And the 3D printing, again, could be done by themselves, but more likely will be shipped out to, what was the name of that community? 3D Hubs. And they can get their parts made. And not just for themselves, which may have been the starting point for this, but actually this could be something that lots of people want to buy. So you take your starting point, you change it into something different, you then upload that, and not just yourself can have it, but if other people like that, they can have it. And I know some communities will even have a voting system where they ask lots of people to submit a design to a particular brief, and then they'll vote on which design or designs are going to be manufactured, because the more people who want it, more sense it makes to get it 3D printed. So that's what I've called crowdsourcing. And there are a number of websites which are aimed at doing this, allowing people to upload their designs, and not just for themselves, but to allow other people to use those designs as well, or to ask for copies to be made for themselves. And very usefully, it tells you how much it's going to be, and you can select different materials, different finishes, and end up with a different price. So here's one called 3Ding. another one called Thingiverse, which is linked in with MakerBot, and another one called My Mini Factory. And so what we are seeing is that certain people are happy to not just design for themselves, but to release their designs for other people to take hold of as well. Now, all that's fine for things like maybe little action figures or rings that go on your finger. But the problem that we've seen at Loughborough is, what about when your products become more complex, more engineering related, and you then have questions about how do you maintain functionality, and especially how do you maintain safety? Because if we let ordinary consumers design something that could possibly, well, it could possibly not work, that's not the end of the world, but if it's dangerous, then that could be potentially life-threatening. So how do we try to marry up the innovation that some people want to create their own designs, but also constraining it so that the function and safety are maintained? And the idea, which we're using at Loughborough, and we're not the only people doing it, we're calling it co-design, or other people call it collaborative design, and so on. And going back to our model before with the individual consumer and the designer, the model we are following is not to try and replace the professional designer, but to actually bring a collaboration between the designer and consumer. Now, this has been done for many years, but the difference is that we want to do it using software rather than actually sitting the designer and consumer down together in the same room physically, because the time for doing that just isn't available. And once again, we're aiming for 3D printing to become the manufacturing tool for this to use. And again, it could be just for the person to make for themselves, or it could be something they want to make available to others also. Now, I'll try and show you the principle we have behind this. It's very simple shapes, but basically what we're saying is, within the product, there will be what I could call a black box of functionality that is defined by the professional designers and engineers. And by saying black box, I'm using that term deliberately because it's something that can't be touched. Okay, other people call it a sort of a safe region. Okay, it's something which is off limits except to the professionals. And so you have to define which parts of your product are functionally critical and safety critical. First of all, functionally critical, and then define that. And then beyond that, you say, okay, also, there are certain limits beyond which this design can't be changed. And we could call that our safety critical limits. And once again, this space will also be defined by the professionals, the people who should know what makes a product work and what keeps it safe. And so what you end up with is, if you like, a core functionality, and beyond that, a scope, a space for design solutions. But they are constrained in different ways. So we have, and then what we allow is the white space in between becomes the space for design solutions. And this is where we can allow consumers the freedom to tailor the design, to change the design into what they want. And what we might do is actually give them a starting design. And the starting design might be something that's very neutral, such as this boring ellipse here. But what you allow them to do is to start moving, actually changing the shape of the product, maybe selecting a different range of functionality, but still keeping it within predetermined limits, and certainly making sure that anything they do is kept safe as well. So, for example, if it's going to be a handheld product, you wouldn't have a radius going lower than a certain value, because the sharp edge would be dangerous. So these are sort of limits that have to be designed into the software. But once you've done that, then the freedom is there that different consumers can create their own designs. And some might be quite boring like this, others might be quite weird. And one of my colleagues hates this because he says, but they'll design ugly products. And my response to that is, beauty is in the eye of the beholder. If that's a product that he or she wants, that's a product they can have, no matter how ugly the designer thinks it is. But there is an important aspect here, is that if that product is still going to be branded in some way, then an extra constraint you might put on it is to keep it within the company brand in some way, or if it goes beyond that, say, well, we don't want anything to do with it. But some companies are very interested in allowing some freedom, but keeping the branding image. Now, how we're tackling that, and this is one of our more simpler versions, but we're creating what we call mass customization toolkits. These have been done before, but the difference is here, rather than just selecting from predetermined alternatives, which is what we can do in something like Nike ID, here we allow the consumer to go in and start changing the design. This is a very simple one. It's a lampshade. The functionality here is quite limited. It's just to make sure that the light bulb does fit inside it, and that we can also do a check for the opacity. Is that the right word? Opacity. Does enough light come through it? And what we can allow the consumers to do is this is the neutral design that they start with, but they can change it to a number of different, here's a cone, but a number of different shapes. They can then go into individual parameters and start moving those around, either by slide bars or click and dragging. They can add different materials, different patterns. They can select different materials. And we also want to bring in some physics. So for example, for some products, it might be important that the center of gravity is, in this case, you'd want to remain down the center, otherwise your lampshade would go like this. So you can build in some physics rules as well. And this is some work done by one of my PhD students, Hessam Yavari. Now, this is a simple product. We're trying to work on more complex things like watches and mobile phones, but the whole cleverness is getting the software, one, to get the software to work, but two, to get the designers to create unfinished designs. Now, designers don't like doing that. They think that their design is perfect, and that's the one that should be released to the market. And to say to them, no, you've got to create a design that other people can mess around with, not every designer is happy to do that. And that's maybe we have to train our designers to think in new ways to create unfinished designs. So then, just by way of closing, a few lessons I think we can learn from how innovation can be driven by 3D printing. It certainly is offering new manufacturing opportunities. We're seeing that both at the low-end 3D printing, but also with the high-end additive manufacturing machines. Professional designers have responded to this, and we are seeing some very interesting product innovations, both in the sort of consumer market, but also things like aerospace and medical and even automotive. But we think what could really start making a big change in terms of the uptake of 3D printing is to work in new ways. And the business models I'm thinking of are allowing us to empower who I would call non-professional designers. Now, not everybody's going to want to do this, but we find actually if you don't expect a blank sheet, but allow people to start somewhere and change it, we now find that about half the population, the general population, are prepared to do this, especially if they think that the end result is something that's going to add value to their lives in some way. And for that to happen, we believe also professional designers must learn to accommodate that in their practice, no longer expecting to design just a finished article, but to design something which can then be changed, and knowing how to create those limits within which the consumer must be kept. So thank you very much for listening, and I hope we've got some time for questions, have we? Okay, thank you.
Please, do we have any questions? Yes, Phil.
Yeah, do you think the idea of personalization is going to become a norm, or will it be a value add? Are consumers just going to expect it like they do with everything else?
I think in some markets that could become the norm. Certainly if you think now with in-the-ear hearing aids, I think most people expect those to fit perfectly nowadays. Whereas when they were first invented, that probably wasn't the case. Now, I know that's a different type of personalization. I think you made a very important distinction between what we had called body fit personalization, where the consumer is passive, and this sort of inventive personalization, where the consumer is active. So I think in certain marketplaces, consumers might start to expect that, like things like dental implants. They might expect them to be personalized for them. Now, that's, again, body fit. when it comes to doing the personalization yourself, I don't think it's ever going to become ubiquitous because some people, for a start, aren't going to want to spend the time to create their own design. So I think, although we think it's possible to expand it from this 10 or 20% of the kind of makers to a larger community, I don't think it's ever going to become the way of making any particular product. I think it will be a way of adding value to certain products.
Yes, please.
Yeah, it's me again.
No.
Yes. Well, I'm just to comment on that. When I went to school, it was mandatory to learn how to handle a sewing machine.
Yeah.
And most of us, I think most of us have access to it. But how many here have made their own clothes? How many brought their own garment? I think that gives an indication.
That's your 10 to 20%.
Something like that. But what you're doing, which is very interesting, you're actually creating a service that would enable people to do this. But we should not forget that many of the things that are being predicted about additive manufacturing now or 3D print now was also predicted about CNC milling when that came around. There are articles that in the future everybody's going to have the CNC milling machine in the basement.
Yep.
And we're going to go to the library and download and borrow designs and programs.
Well, that's why I think that our distinction, that we aren't expecting these consumers to make these products. We're expecting them to design them, but they'll be made professionally somewhere. And I think, but even then, how many people are really going to be willing to log in and play around? Our early estimates are about half the people we've dealt with, but then there has been a bit of a skew in that a lot of our research has been done with younger users who might be more, especially people who are used to gaming and maybe creating their own characters and so on. But they are the future marketplace. So why not? If they can do it for gaming, why not do it for other products?
Possibly.
Okay, Olaf first.
Just to continue your thought, when you were talking about people doing their own designs, and we end up with a lot of bad design.
Yeah.
And you say, beauty's in the eye of the beholder.
Yeah.
But I sort of always wonder about product sustainability, where if a product is, I'll use the words badly designed. That person may like it for a week, but after a week they get bored with their bad idea and throw it away.
Well, we've actually found the opposite. We find that when people invest time in designing a product, even if I might think it's an ugly product, they form an emotional bond with it. And they actually like to show it off. So, although, they might get bored of it, that's true. And at the moment, we haven't done a longitudinal study to see what happens, but it could go that way. But we certainly have found that people, I wouldn't say fall in love with their products, but they feel a sense of ownership. This is what I've done, and they're happy to let other people see that. Now, if other people keep telling them, well, I think it's terribly ugly, then perhaps they might stop showing it off.
Phil?
It was just an observation following on from Klaus's product. Sewing machines are the fastest growing domestic electrical appliances at the moment. Yeah. So that's just as an aside. Yeah. Massive resurgence of people making again.
Björn?
Yes, Björn Nilsson, Eva. How much of customization do you think in the commodity market would be restricted by cost and therefore price? Because a commodity lamp from IKEA would cost like €3, and I saw a price tag of £263, which was probably some kind of guesstimate or joke or something. But if it's true that it would cost hundreds of euros or pounds, it would, of course, limit the market size. So how do you think you can push cost and therefore price?
Well, I think we are seeing at the moment still a lot of 3D printing processes are expensive processes, especially the high-end additive manufacturing ones. But the quality of the low-cost printers is improving all the time. And Phil talked about some of the kind of process monitoring and so on is being built into it. So we expect in the future that these costs will decrease dramatically. And at the moment, yes, you're right, it might be very, very limited to people who do want their own bespoke product, and that tends to be probably wealthier people. But in future, those costs will be driven down, and therefore the market should grow.
Thank you, Ian. I think that was the last question. A very quick one.
Quick one. Pearl of Loof with the Chem Electronics. we just celebrated the 30-year anniversary of Back to the Future 2.
Yeah.
And
Yeah.
and we make electronic components. We're very fascinated by the flux capacitor. But anyway, that's a different story. But when do you think that the 3D printing machine will be sort of part of a normal household? So, you know, instead of having maybe added to the toolbox, you will have some sort of a consumer 3D printing machine in the cellar.
Well, it's interesting. One of the companies, MakerBot, it was their aim. They want to get a 3D printer into every household. I just heard that they've had to lay off 20% of their workforce. So I think they're actually maybe thinking that was too optimistic. Myself and Terry Wohlers have discussed this, and the conclusion we've come to is that it'll be, what do you use a 3D printer for in the home? Okay, people say, oh, it'll be just like the PC. We'll use it for everything. But look what we use computers for. We use it to do things we used to do either by hand or printing out photos or looking at photos or doing our accounts or writing letters. They were all things that we did in the house anyway. How many people actually make things in the house today or would want to? So we think that those printers getting into households could still be limited, even in future, to that sort of lower percentage of the maker, the DIY people who currently like to have a go at doing things, maybe using a sewing machine or maybe using their drill in the garage. So those people, yes, they'll want a 3D printer, but the majority of the population may not. That's my personal viewpoint.
Thank you, Ian. Then I would like to present our last speaker, Bill Cass, partner of Cantor Colbert in the US and also co-chair of the litigation department.
Thank you very much, Anne-Louise, and thank you, IVA, for inviting me to come and speak. First of all, a little bit about myself. I have a mechanical engineering degree. I do work in the aviation space a little bit. I'm a commercial multi-engine instrument-rated pilot, an advanced ground instructor, and I'm licensed in a Citation jet as a co-pilot. And, you know, the other day last month, I was doing some spins in an aircraft, and I have to tell you, as a pilot, I'm not ready to have structural parts made out of 3D printing. And I don't think the FAA is quite there yet. I think I can offer a little bit of insight on that. I authored Rethinking Additive Manufacturing and Intellectual Property Protection with Dr. Tom Kerfis from Georgia Tech. He was actually President Obama's lead in developing the public-private partnership in additive manufacturing in the United States. And I've also written on the legal implications of additive manufacturing in the Wohlers Report. So normally I focus in on the IP. I do still do some products liability cases. I'm working on a gas explosion case right now. But additive manufacturing is going to be somewhat of a disruptive technology in almost every way for the legal community. And I hate to tell you, you know how people were copying music files and it took the Congress and the lawyers to figure it out 7, 8 years later? That's kind of what we have going on here. The patent protection is pretty well known, but a lot of the products liability stuff hasn't really kicked into gear yet because we're just starting to get body implants that were made out of three-dimensional printing. We haven't yet had catastrophic accidents happen because of a product made with additive manufacturing. So we're a little bit behind the times in the legal community. Remember how Ralph Nader in the States, and we are the most litigious country, I think, in the world, how he got his start, unsafe at any speed. It was because of the crash-worthy doctrine in a car. You know, they used to have shift levers that would impale you if you got into a car accident. Think about it. So we haven't really got there yet, but I do know that an airliner was brought down in Japan because in a service bulletin, the mechanic didn't put in all the screws on the bell crank in the back of the plane. So that's the level of safety they have to achieve. So we look at IP, we look at products liability, we look at technology transfer, and I'm going to talk about one of the big implications of this technology is going to be the ability to copy designs and take those designs quickly and use them quickly before IP can even catch up. Then you have government regulation. You've got medical, aviation, defense. That's known throughout the world because you have new materials going into the body. You've got certification by the FAA. And then you have issues of contract law. I'm going to electronically transfer you my design. What are going to be the implications of that? Who's going to, what are the contract rights going to say about that? So let me start out with products liability because You know, in the United States, you can be sued if your product is unreasonably dangerous, if it was negligently manufactured, negligently designed, or if you failed to warn someone as to how it was used. So the way attorneys will view this in the United States, they will say, what's the biggest company I can sue? Do I have big injuries? And can I make some money if I sue them? And they really don't care in the United States if they sue a lot of parties and they have to let a few go. That's going to be their aim. So it used to be for products liability, you had to have what they called contractual privity. I needed to buy it from Olaf. But let's say he sells me a car and then I sell my car to Ian. Well, why shouldn't Ian be able to sue for this negligently made car because he bought it from me? So they sort of have done away with contractual privity as a means of preventing lawsuits. So I'm going to submit to you that if a product's unreasonably dangerous, no matter who designs it, if they have money that an attorney can go after, they're going to be a target. It's just the way the world works, especially in the United States. But we are not the only country that applies these principles. So you got to start thinking about, okay, product origin, direct distributor, reseller. Was it negligent design? Was it defective in manufacture? Failure to warn? Did it cause injury? Who's the responsible party? Is it the manufacturer? Is it the designer? It's the seller? Is it the owner? Okay? The litigation folks will go after anybody with money. And that's the reality. That is reality. So how do you mitigate against that? I guess is the real answer. And there is ways to mitigate against it. One is through insurance. That's the best way to mitigate your business if you're going to be sued for negligent design or negligent manufacture. Okay? Contract. If you're having somebody make your design for you, you want to have an indemnity provision. What about false goods or the theft of your designs, encryption, watermark? But there really is no solution. People say, well, how can you absolve me of any liability? I can't. No lawyer can. Because if the product is unreasonably dangerous, they're going to go to any target that has the ability to pay. And that's the reality. So, so we look at government regulation. You've got to have approval, certification. And again, you can have issues in negligent manufacture. So I'm using 3 areas here. We've got medical, aviation, defense, and there's the Airbus bracket. My understanding is that bracket's actually holding conduit in the aircraft, and that it's not quite, the FAA is not quite ready to say, oh, we're going to allow a structural component that holds this aircraft in the air to be made by additive manufacturers. It's not quite there yet, because the implications of a mistake are huge. So let's look a little bit at some of the IP issues. Now, first of all, most countries are a participant in the International Patent Cooperation Treaty, okay? And it's interesting because the United States was #1, Japan is #2, but China supplanted Germany as #3 last March. So there's some unique challenges from 3D printing. So first of all, my little figurine here is protected by a copyright. Okay, there's an issue of him being a famous person as well, but I can protect this instantaneously because it's a piece of art with a copyright. This impeller is a lot harder to protect because unless the impeller itself is entitled to a utility patent, it's open season on this impeller. And the reason is that, a design patent only protects something that has an ornamental appearance. But a utility patent could cover this if there was something unique about the blades, about the airfoil, but it may not be entitled to protection at all. And it used to be that somebody would have to get, plastic injection molding equipment or some kind of heavy investment to make these parts. So why is the technology so disruptive? So in 1995, a laser scanner, like the one that Faro makes, it could scan 600 points per minute. This scanner can scan 500,000 points per second. That is the technology, that's one of the technology differences. So now I can go and I can scan Olaf's guitar here. I'm picking at you. I've got a picture of you later, I'll show. I can scan that. I can render the data. Now, it used to take days to render the data. Think about it. You used to have a computer science degree and sit around for a couple of weeks to take all that data. But now, as software is helping that, we're accelerating this ability to move the data into an STL file, to print it, and to make the object. So where are the lawyers in this process of protecting you? Well, you apply for your patent. This is the US, but this is not untypical throughout the world. It goes into examination, and 2.5 years later, the patent office comes back and says, well, I don't think it's quite patentable because of this reference or that reference. You start arguing with them. Yeah, your patent might issue in 3 to 5 years, right? And then, oh, I want to sue. This person is copying my patent, and I've got lots of money, so I can sue them. So in the States, 3 to 5 years after you start your lawsuit, because you can't sue until your patent issues, well, now where are we? We're somewhere between 8 and 10 years after the product was designed and made, and technology has probably moved way beyond it. So we might be making patent lawyers obsolete. I'm not sure yet. Real life story. I litigated a case in Boston, Massachusetts. It involved over $50 million. And the patent itself was applied for in 1995. And it went through the International Patent Cooperation Treaty process, became a US patent. A lawsuit was commenced. That case was tried in 2012. Just to give you an idea of how lengthy this process is. So, let's talk a little bit about forms of protection, because in some ways, the copyright is still there for artistic works, right? You can still have an instantaneous, if you make a very popular figurine, and you're going to sell it, well, you have protection for that. You have protection for your Star Wars animal, creation. You have protection for Mickey Mouse. That's copyright protection. There's rights to those designs and characters. One thing that I do see that may happen is this concept of trade dress. A lot of people forget about what trade dress is. So this Coke bottle started life out as a design patent in 1915. And over the years, people came to associate the shape of this bottle with Coca-Cola. So a trade dress right is like a physical copyright, a physical trademark, a physical trademark. That's why, as much as I love a Ford Mustang from 1964, I can't go make a Ford Mustang from 1964 because Ford owns rights in those designs that have acquired a distinctive meaning. So it may be that trade dress becomes more important. Design patents are often used by the automotive manufacturers to protect bumpers and grills and seats and lights so that the aftermarket folks can't take a stab at trying to use their parts. And then they feel, okay, after our design patent has issued and expired, we now have trade dress rights because we've protected the look of our product for all those years. So you also see this in consumer products. So trade dress gives you exclusive use, and you can develop those trade dress rights, and you can use a design patent to do it. So, but going back to how do we protect this? I'm going to skip trademarks for time. Utility patent. It can only protect functional aspects of the invention. It's got to be useful. It's got to be new and not obvious, or a new material. It typically takes years to obtain, maybe 10 years. Expensive. The average patent case in the United States, does anyone have an understanding what it costs just to bring it close to trial, is about $1 million. So you get your patent, you want to enforce it, you better be with a large company or somebody who's well-heeled. So why would you patent or not patent? So reasons to patent: can the invention be easily reverse engineered? And that's a kind of a tricky statement because we can really reverse engineer just about anything these days with gas spectrometry, EDX, different kinds of technology. Asset development, because people are still interested in companies that have IP. Attracting investment. Marketing, discouraging the competition, making sure that if you're going to come up with a new design, many, many times we have to then go through and make sure it doesn't infringe some IP that's out there. Defensive strategies. Many, many times a company says, oh, I want to go sue them. And we look at their patents, we say, well, maybe you ought to let sleeping dogs lie because they have a lot of patents and they may end up suing you. So that's just an example of defensive strategies. Now, there are a lot of reasons not to patent. One is, of course, attorney's fees. There's maintenance fees. They're not always successful. You have to publish how to practice that invention. You have to teach someone of ordinary skill in the art how to practice the invention. What happens if you file that patent, it gets published, and nobody thinks you're deserving of a patent? It's already out there in the public domain. Difficulty in enforcement. Process patents are a really good thing to think about whether you really need to patent it, because if you have a process, and let's say that you've got a chemical additive, and in that manufacturing the chemical additive is eliminated so that when you look at the final product you can't see that chemical additive, well, that's not a really great reason to patent because you're just teaching the world, and you might not be able to tell whether the competitor or the infringer is using that chemical. So, and then also cost enforcement. So what are some of the solutions? So a lot of people ask me, they say, well, what's the most important form of intellectual property protection? It's not a patent, it's not a copyright, it's not a trademark. It really comes down to a good IP agreement, because first of all, you need employment agreements to make sure the people that are working with you aren't going to take any of your company secrets. Now, many countries have some base laws that cover that. The United States does as well. But a lot of times people are not thinking, and they're saying, oh boy, joint development agreements. You know, a lot of people don't realize that when Bill Gates with Microsoft was working with IBM, he retained all the copyrights in the MS-DOS software. I think he got the better deal, that arrangement, right? Because that entire company was built on the fact that he retained the copyrights. And in the US, there's actually some default provisions under copyright law that if you develop software, you retain the copyright in the software. And so sometimes we're involved in mergers and acquisitions, and boy, we find out that, oh, yeah, we had this company develop the software. Well, let's see the contracts. Who owns it? And the company, the target company, doesn't even own the software to what they're using all the time. So you have to consider that. Ownership. We do business with you. We jointly develop this. Who's going to own it? Who's going to have the rights? Now, just as in personal relationships, in business relationships, sometimes there's divorce and hard feelings. Sometimes people part company. So then who owns the IP that was developed? All of these things can be addressed with the IP agreement or with the license. So it's flexible because you can use an IP agreement or a contract in any situation. You can customize it. It's expedient. You can get a contract in a couple of weeks or a couple of days or even an hour. Your patent could take you anywhere between 5 to 10 years, depending on whether you're taking those patents and putting them off into foreign countries. And you can add additional protections. Remember, we're talking about products liability, warranties, representations. I represent to you that my product design is free from any claims to intellectual property. I will bear the cost of any insurance to make sure that if we're sued, there's insurance to cover it. Now, some of the things about insurance policies in the States that are tricky is that not every run-of-the-mill insurance policy covers a negligent design issue. So if you are manufacturing products and you're sending them overseas, you should spend some time with your insurance agent. The insurance agent might be as equally as important or more important than an attorney, because in this world you've got to see what kind of protection do you have for the activities that you're doing. Because ultimately, there is no way to stop a lawsuit in this field as in any other field. So the other thing that we need to think about is some global strategies on the IP side. One is the Patent Cooperation Treaty I mentioned, the European patent application. With one application, you can cover a bunch of countries and save expenses. the Hague System for International Registration of Industrial Designs. You can register up to 100 designs in 62 territories with a filing of a single international application. Remember, I was talking about trade dress rights. So if your product, you think your product's going to have some kind of a trade dress right, or it's going to have a certain appearance or certain look, and looking at these products that are even on the table, you can see that some of these don't have a functional purpose at all, but they're entitled to a copyright protection. Or you have all yours made in with a certain logo or a certain look. This is one way to start developing those rights, because you can file design registrations on them and get the protection over 62 countries by a single application. So a couple other things. So we have the European patent community. We really don't have an Asian and Pacific patent community. They have a regional bureau, but it's just sort of hovering there. It hasn't been a lot of activity. I think that might change eventually, because companies are, especially China, is looking at doing lots of filings. Other countries are trying to catch up out there. They're going to be looking at ways of saving money, and perhaps we'll see a regional patent application in that area as well. So many exciting times, because many of the primary patents in this space have expired. Fused deposition modeling, this one's expired, even the one with the support filament. Stereolithography, that's expired. Laser sintering, that's expired. But be careful, because there's something like 6,000 patents in three-dimensional printing have been applied for at the Patent Office in about the last 7 years. That's a lot of patents to be cognizant of. Where are they? They're in materials and object support, special properties, hardness, glass transition, fillers, porosity, treatments, vapor deposition. So when you're entering into a new space, you've got to be very careful where you're going. What do you do, and how do you do that? Well, a lot of times I tell people, you can do a little bit of homework yourself. You can go out and say, well, who would be my competitors in this field? And you can start looking at their patents. And then you can start looking at category and classes of patents to try to say, hey, are they in that same space? Is anybody else in that same space? A lot of times we do what's called landscaping, patent landscaping, in our freedom to operate. And we do a little bit of inventing there too, because we figure out, okay, this company's in this space, this company's in this space, they're doing it with this, they're doing it with that. Could we come up with a new way to do it and a different way to do it? And also, sometimes we do things called state-of-the-art reports, where you're looking at what have people recently patented on that subject matter? Because that's a trend, too, of where innovators are going in the space. Some more examples: build chambers, heating cabinets, moving platforms, conveyors, internet protocols. Now, this is interesting because in the United States recently, I say recently, a year ago, April, our Supreme Court reduced business method patents, and a lot of these internet-styled patents may have some problems in enforceability. Physical components, UV lights, lasers, liquefiers, dispensing systems. So what is the key to success, when you're trying to move forward with a new product or a new avenue of invention? Well, you've got to do due diligence. You've got to make sure that you have the right to use the technology. One time I was asked to clear a medical product, and the company had already spent, quite a bit of money investigating it, and I was like the last one in the food chain. And they asked me to do a patent search, and I looked at some patents, and there was a company in California that had the whole space pretty well blanketed, and they didn't even know of this company or their patents. So you've got to get out there and do some due diligence. You've got to have a well-drafted agreement with your business partners, your employees, anyone else you're going to do work with. And you've got to think about formal protection if it's applicable. And then I say dual protection. So that, in a nutshell, is a tour through all the legal implications of additive manufacturing. And I'm open to some questions if anyone has some.
Thank you, Bill. Questions? Yes, please.
Thank you very much. My name is Anna Saberström. I'm working at the Swedish National Board of Trade. And I have a little bit more questions about product liability.
Sure.
Because I'm not just, I don't know anything about US liability laws, but I know a little bit about EU legislation, product legislation. And in this respect, you need a producer who is liable for the product, mainly placing the product on the market. But as we have seen, there are lots of different business solutions where you don't see the borderline anymore. Who is the producer? Who is the consumer or the designer of the product? There, for example, business solutions where you're just sitting in front of the computer using a designer program, just putting on the return, and there's a printer in another country starting to print your product. And there are business solutions where maybe these service providers saw that there is a risk that they're seen as a producer and that they should have the producer responsibility. But they said, oh, now we are renting the machine to you, and we are selling the material to you in beforehand. So we're not the producer, we're just a service provider. And I'm interested, is there something in the US discussed about that? How are you regulating these new business solutions? How do you tackle with that? Thank you.
I think that's an excellent question, and it's almost an unanswered question at this point because it's just starting to kick into gear. But the way U.S. litigation works is if you can show a party was negligent, and that meaning that they failed a reasonable standard of care or that their product was unreasonably dangerous, and that there was a causal relationship between that negligence and the injury, that's all you need to establish. So, taking your example, if I'm the service provider and I'm just hosting a website and the design is up there and I have no knowledge as to what the design's used for, whether it's safe or dangerous or whatever, that's a hard case to make that claim of negligence, okay? Because you can't just sue anybody. But if I'm the service provider and I'm hosting all these designs and I get all these emails from different people and they're saying, hey, look, take that bracket down because people are using it in, the shock absorber assembly of a car and it's breaking and it's causing accidents, and the company doesn't do anything. In the United States, they would be a target for a lawsuit. And there's a couple things that drive lawsuits in the States. Can the entity pay the judgment? That's the big one, unfortunately, but that's true. I mean, they're not going to sue somebody in their backyard who has no money. But if they're a multimillionaire and they cause a loss, they will get sued, whether they're, it's tough. It's tough. And that's kind of like the liability that's always associated with aviation. Every time a pilot gets into a plane, there's nothing you can do to eliminate the risk of a suit.
Yes, please.
Coming a little bit to the same point, but in a much more limited case, I work partly with the International Olympic Committee for approval of equipment used in bicycling or whatever. And here it's a big problem. For now, there are coming out products that are not safe.
Right.
On bicycles, especially where 80% is aerodynamics. So now, how do we approve them before racing? If there's an accident, who is responsible? Many times is the organizer, UCI, the federation, and it's impossible to handle. For there's so many different shapes coming out, and we cannot handle it.
Right. And I don't know how we would do it in Sweden. In the United States, you'd have to buy insurance for your events, and then you would have to, probably, you have to buy insurance for the event, and you have to have disclaimers to say, look, we're, each entrant is responsible for the design of their equipment. I think in a situation like that, even in our host country, which I'm candidly admitting is a very litigious country, I think you're moving away because you still have to have causation between what you did or you didn't do and the injury. And that's the thing about products liability. There's some jurisdictions in the United States that say if you sold it or designed it and it's dangerous, you're strictly liable. The only question is whether or not it was unreasonably dangerous, and that, but they would still have to show that you had some sort of a cause, some sort of causation between your activity and the dangerousness of the element, if that makes sense.
Please press the mic.
Have to sign. I take my own responsibility for my. I don't know if it carries along, but that's the only way to go.
In Massachusetts, there's only one situation where those carry weight, and that's in the ski industry. That's actually one of the few.
It's what I'm talking about, ski and bikes.
Yeah. They wouldn't apply it to bicycling, but in the States, the ski industry has managed to allow those waiver of liability forms to actually have some meaning. In most jurisdictions, you sign it, but it doesn't really mean too much. It's still there. So.
Yes, please.
Do you foresee, due to the grayish area of who's responsible for putting the design on the market, that the number of design protections or trade presses will decrease, or utility models, so the number of applications will fall?
I think that they could decrease. One of the things that Dr. Kerfis and I suggested to the United States, because we don't have this system in the United States, but Germany, as an example, has something called the utility model, and I think Sweden may as well, where instead of applying for a utility patent, oh, they don't, instead of applying for a utility patent, you apply for the special kind of petty patent, and it's a 10-year grant, but it doesn't get examined unless it's going to go to litigation. So it's a much less costlier way to get your patent application on record and potential, and it's out there. But it is a real issue, because with the ability of a scanner to scan 500,000 points per second, and they're now going to have white light cameras where you're going to be able to take a picture and you're going to be able to get the measurement data at an extremely precise level. Imagine it only takes that long, and you've got softwares to automate that rendering process, as I was talking about. The patent process may not be that helpful in terms of protecting your products and your designs, and maybe the embedded 3D printing aspects of it that are encrypted may be a better way. Again, you would be keeping it as a trade secret as opposed to a patent.
Yes, please.
Bill, just some of your thoughts on the future of, patents in particular, when you talked about the timelines involved in getting a patent and then suing somebody. And to my mind, one of the things that's changed the product development cycle is 3D printing. We're now developing a product takes weeks or months or a year, whereas 25 years ago it would take several years. So, with the speeding development of product development that 3D printing and CAD and the various other technologies like digitizing allows, in 20 years, will it still be worth getting patents, or are we better off just innovating faster to get new products to market?
I think there's a big debate in that, because a lot of these litigations, and they're really big in the United States, these patent litigations generate lots of attorney's fees, but not always a lot of result for the clients. I mean, you have the few big wars between Apple and Samsung, et cetera, but the average run-of-the-mill patent litigation is so expensive to bring, so expensive to defend. They did, because we have this troll problem in the United States. Maybe some of you have heard about it, but people get these very broad business patents and they try to sue entire industries. 3 years ago, Congress in our nation created a new process called an inter-parties review, where you can, if you're a defendant, go to the patent office and say, hey, this patent's no good, and you do a little mini trial there, and the burden of proof isn't so high as it is in federal court. So that's one thing I see, and I also do think that we're going to have to rethink the patent process. Are we going to go to more of a registration process, and then if there's a need for litigation, the patent gets examined? I mean, I think eventually they're going to have to look at a different process, just because it's moving so quickly. It's so expensive. Even to take one invention from the U.S. and impart it as a patent throughout the world is $100,000 between foreign attorneys' fees, foreign government filing fees, and you start to see, if you have 10 or 20 patents, you're talking serious money. So who has all these big patent portfolios? It's huge corporations. And so that's kind of what we're seeing. So I think it has to change if we're going to be productive. So,
thank you, Bill.
You're welcome.
that was the last one of our speakers, and now we'll have commentaries from first Anna Valtonen, who is the Dean of Aalto University School of Arts, Design and Architecture, and Vice President of Art and Creative Practices. Welcome, and she will give us 5 minutes of commentaries. Either here or there.
Whichever works.
Yes.
Thank you. And thank you for all the speakers. It's been a great joy to listen to all of you. I think you've had very inspiring talks, and I think you very well answered the question that Eva put forward, whether 3D printing has actually reached the tipping point. Clearly it has. And that's, of course, something I know from my own world as well. Working in a university, we have additive manufacturing labs. We have 3D printers of different kinds in virtually every department. We can do it on a consumer level. In Helsinki, even in libraries, they're there, so all the children can do. And also, so in many cases, of course, we've answered the question, but still there's something, I think, that made me think a little bit, and that's really, have we answered the main question? Why? What's in it for people? Why would we do this? What will actually make it explode? And quite a few of you actually talked about the previous industrial revolutions and the hype that's around this and so on. And if you allow me to play a little bit with the thought, because it was Phil who talked about the previous industrial revolution in 1840, 1890, you dated the material innovation of steel, right? So if we play with the thought of this being the steel bar, then I would say that Olof's talk was really trying to address those people who are used to the forge. You try to explain that, look, we can do steel bars. They can be combined in these ways. It allows us all these great opportunities. Phil, you talked about, yeah, but there's new societal needs. Maybe we can make the steel bar into a train track and actually move people in a faster way. Ian, you were talking about, or actually, you talked about aesthetics as well. And that's another thing, important point here is time. How long does it actually take for these innovations to really be societally impactful? I think the aesthetic question is really, it's the Eiffel Tower, right? It took all the way to 1900 to make an aesthetics that was very typical to the steel bar, even if they invented it, like you said, 50 or so years earlier. Then you came, but now we can produce all these industrial products. Shouldn't we design a concept like the department store so that people could actually consume in their leisure time and be inspired by new ways of doing it and that whole new concept? And listening to you, William, I think that period was really when lawyers came into power, wasn't it? So it all was really tied into that era. But to me, the big impact of that revolution was really when, take Sullivan, he started building high-rise buildings. They were great as such, but it was really the point that it made people move together. Urbanization happened, and it didn't happen because we had the steel bar. It happened because it made people get a better life. They could actually get a better job. They could be close to peers. They could exchange ideas near to each other. And that's what the whole idea of modernism was to me. So it's really that exchange of thoughts which was made possible by the steel bar, but it wasn't the steel bar that made us think. And I think with 3D printing, we're sort of in a similar kind of crossroads, because quite a few of you have talked about it allowing new business models or new ways of interacting or new ways of making the end user or the individual the producer. But it's really the what's in it for me question, which I think we're still looking at. I mean, what is the urbanization, not the 3D printing? What is the future which will make people passionate about this? It will be there, and we're very close. But last time, it took us, say, 60 or so years. So if you now said you started with 89, we might still be a little bit away from realizing how this becomes a passionate part of everyone's life. But it will change society, I have no doubt about it. But I'll be looking to see the next one where we're looking at what is the urbanization of 3D printing. But thank you for those inspiring talks to make me think about it. Thank you.
Thank you, Anna. So finally, we have some thoughts and comments from Lars-Erik Renner, Associate Professor in Mechanical Engineering at the Mid-Sweden University. Please.
Thank you, Anne-Louise, and thank you for your passionate talks previously. So I'm an associate professor. I have been doing additive manufacturing for more than 15 years now, actually. So I started off with the electron beam melting method, which I guess many of you knows, manufactured by the company Arcam in Mölndal, Sweden. But anyway, so additive manufacturing, what is it in it for Sweden? That is, I think, a very important question. Many of you have heard before that, and I've told you before, and I think Claes have told you before, that Sweden is maybe at least 10 years behind in the usage, you know, within industry, but also within R&D, within the area of additive manufacturing. You know, we are way behind the fellow European countries and other initiatives throughout the world. And this is something for me as a, you know, professor at the university, this is important to change. So, Phil, you talked a lot about the you know, the future trends and the drivers that the companies has today in order to change their product development process, you know, to fulfill this aging population, etc., etc. And when I'm thinking about Sweden's position today, what do we have and what are we very good at? ICT, of course, you showed the Spotify, the Skype, etc. That is an area that is important for us in Sweden today, and is certainly a very important area that we need knowledge of in order to promote additive manufacturing even more in the future. Well, I do a lot of research within additive manufacturing metal, so considering this specific area, we have maybe an even better position actually here in Sweden, because we have many of the, you know, biggest metal powder manufacturers in the world here in Sweden. In small country of Sweden. I heard something that we are manufacturing maybe 30–40% in total of all the metal powder in the world, which is quite much. And this area, I think last year, maybe you guys could help me, I think it grew with 70% last year, the additive manufacturing in metal specifically, and in general it's something like 30–35%. So we sure have a very good position if we want to take a big step, you know, forward and try to be even better and bigger in the area of additive manufacturing. But we need, in my opinion, to sort of consolidate our efforts here, because right now, within the universities especially, we see a lot of initiatives, but they are quite small. And I'm not sure that that is the right way to go if we want to do a joint effort and do something really good together. We need to sort of formalize our cooperation together with companies, of course, but also within the universities. Finally, so what I would sort of dream of, or my wish today, is that we need a sort of national initiative within the area of additive manufacturing. We have a lot of small initiatives, but we need a bigger one that is, you know, comprising not only metal additive manufacturing, not only design, but we need together all these aspects that we've been talking about earlier today. Everything from designers to material scientists, maybe even human sciences and so on, in order to really do a good work and, you know, try to get this future sort of production method to be even more used here in Sweden. Yeah, that is, I think, my final words, and I really hope that this sort of national initiative should be inclusive, and that we will have the possibility to get some long-term financing, because that is also important. Yes, thank you.
Then I would like to ask the speakers, you stay please, and Anna, to come here, and we'll have the panel session.
Squeeze it.
Yes, please. Okay, so I would like to start. Are you all ready? It's a bit crowded over there. Do you need another table?
I'd like to be cozy.
Yeah, it's going to be cozy. I would like to, for you speakers now, after listening to the comments from Anna and Lars-Erik, anything that you would like to reflect on or comment on back to them? Please go ahead.
I might say I think Lars-Erik is spot on in terms of Sweden, you know, needing to catch up, I guess, with the rest of the world, and some of the, you know, what the answers, what the initiatives are, I'm not entirely sure of. But one point that Anna made, which I guess, strikes a chord with me. She said in libraries in Finland, all the libraries have got 3D printers in there. And if I can just compare it to New Zealand, which is actually where I come from, and it's not dissimilar to Sweden, every library in New Zealand just about has 3D printers, but also high schools. The vast majority of high schools in New Zealand now have 3D printers. So kids are growing up knowing about it. They go to university, they go to companies, they're aware of the technology. And I think how we do it, but that's something that I'd like to see in Sweden, is every high school having 3D printers in their classrooms.
The title of the seminar, which Anna referred to, that 3D printing beyond the tipping point, and you kind of answered to that. What your thoughts? If we actually have, reached the tipping point, or where we're standing, and if there still needs a trigger, and you actually asked another question instead. But what do you say, the rest of you? And you can add something else or something more. And of course, are we there, or do we need another trigger? Ian.
Well, I think the tipping point for me came when I had to stop explaining to most people what 3D printing was. 5 years ago, maybe even less, that was the case. And my kids especially, when they asked, what does your dad do? And they would tell their mates they didn't have a clue. Whereas once they had heard about it and said, oh, that's really cool. And for once, Dad was cool in the eyes of his kids, which is always worth achieving. And I think in a way that for me was a tipping point. A number of things sparked that. I think Obama saying it in his speech is one thing, but also the Stradivarius appearing in front of the Economist was another. But I think catching people's imagination, and I think that's happened. I think now we're going to see an acceleration. Now there is this theory about we'll go too much in the hype and then we'll dip back down again. And I think that will also happen, but we'll eventually come to a sort of a realistic viewpoint, and that may be some time off it, but that will happen now.
Okay, thank you.
I don't think we're quite there yet on the product solubility side. We are on the IP side because there's been already a history of litigation between the various manufacturers of this technology, especially in the United States. So that's not so new. But what I think, for example, metal implants going into the body, sometimes those problems don't even surface for 10 or 12 years after they've been in the body. In terms of automobile manufacturers using structural components and aircraft manufacturers using structural components, I don't think we've gotten there yet. I follow the cases. I don't see any cases in the States that really address this situation where you've had a part, designed by one company, put on the internet, manufactured by another. But I suspect that serious parts for serious products are still going to be closely guarded by the manufacturers, but we just haven't seen it evolve enough. We've seen it on the IP, but not yet on the product's liability.
I'm going to postulate we haven't reached the tipping point at all.
At all.
At all. And I'm going to justify that by saying, and somebody put me on the spot last week and asked me this question: can you name one product that is 3D printed that didn't exist before 3D printing? And I can't. I simply can't. Even dental aligners, it's just a vacuum forming over a mold tool. Dental implants is just another way of making a dental implant. Toys, gifts. I can't think of a single product that didn't exist. When somebody puts a product on a table that is wholly based around the premise of printing it layer by layer, particle by particle, then I would postulate we've reached a tipping point, and we haven't reached that point yet. And that's maybe your urbanization comment. We're not there yet.
I think in comparison to that, we would have invented the car, but it still looks like a carriage without the horse instead of a modern car.
Have you thought something?
So what about a liver or a body part?
Bioprinting.
Okay, but we haven't reached that tipping point yet.
We're pretty close.
Unless somebody walks in the room at the back and says, my 3D printed liver is working wonderfully. Because if they do, they can take me and show me where they got it. But we haven't reached that point. That's the point we haven't reached. And I agree with you. There's a lot of amazing work in laboratories on biomedical applications and cultural applications and glass, but we're still getting there. And I think your point about revolutions, we assume the revolution was the one day in France when the king was kicked out. It wasn't. Revolutions take years, decades, millennia. Well, I wouldn't say millennia, but certainly centuries. Yeah. And you're right. I mean, the first patented 3D printing process was Chuck Hull in 1986, filed in 84. There are patents going back to 1952.
even earlier.
So yeah, some of the original turn of the century stuff about making horseshoes by laminating. So we've been thinking about making things by layers for a good century, but I still don't think we're at a tipping point.
Olaf, do you want to add something? Or your view?
I sort of.
Do you dare?
I sort of agree with both sides. I think in a way, Phil is on the fence, but I think if we're not at the tipping point, we're pretty close. I mean, we're not far away. We're not 10 years away. You know, I think we're 1 to 5 years away, not 10 years away from. And to me, it is. I think once industry starts to really apply it in a more global way, that's when we'll start to see products designed that could only be made and that didn't exist before, and that can only be made with additive manufacturing. But you know, we're seeing it start to happen today, I think.
Eric?
Yeah, I think what we miss still in order to reach that tipping point is actually more, education and learn the people. And when I say the people, it's everyone from, the do-it-yourselfers over to the designers and the engineers. We really need to learn them how to use the technology and what the pros and cons are. Because it's not only, the good things coming with this technology. There are a lot of problems as well, and we need to address them.
I think if I can jump in there, I mean, one of the problems, I think you're hitting it on the head again, is design for additive manufacturing. Probably, 70-80% of the people that come to our lab and say, print me this, it's the same part they would have done on a CNC machine last year or some other way. So they're not gaining any advantage, other than maybe time, but even that, for designing.
Anna, you want to,
Yeah, I just wanted to add on that one. I do think that there was a PhD thesis that came out a few weeks ago, and there's quite a few people working on it, particularly in sort of the sort of parametric modeling kind of things, where the designer actually designs a program which allows the consumer to design something. There's actually plenty happening in that space. So I think we're getting there.
We're getting there, yeah. So various opinions kind of coming together, I think. Yes, please.
I cannot comment whether we reached the tipping point because nobody has defined the tipping point. But I can tell you what my science philosophy is here, and I've discussed with some of the speakers, and what I'm trying to do here in Sweden. So I'll make the problem bigger. So the problem we face, and what this Industry 4 is addressing, is not additive manufacturing. It's addressing the bigger problem, which is called democratizing manufacturing. And that is exactly how we liberated the microelectronics industry many years ago, by separating the designer from the factory. So if you had an idea, you could build a chip without somebody who controlled the factory stopping you. We have tried since the last 25 years to see what other kinds of systems or engineering systems we can do that for, with very little success. And progress has been made. So my view on 3D printing is one other method of manufacturing that has some advantages and some disadvantages. When we design systems, we think of systems design, manufacture, life cycle, the whole thing, and then they become products. I'm talking about products, not toys. And therefore, what's missing here is software environments in which Sweden is very strong. That's why I'm here. They have all the components, and I'm trying to help them to put together, where you actually do that. I mean, a very good example is the 777, I repeat, and the 787, and some of the auto industry, where you think of everything by computer. You don't construct a single screw before you certify, verify everything, and then you produce it. Now, has this happened anywhere else? I don't know how many of you know that Google had a project by the name of Google Project ARA, where they created a software environment to create smartphones, where the components could be manufactured anywhere in the world, and then you put them together. Did they prove it? Yes. Last November, or even before that, they created a smartphone for less than $100 and produced it. All the components were manufactured in India. Some of them were additive manufacturing, some of them were not. And I think that's the bigger picture. And there is a place for this, but unless we reach this environment where we can actually do all the things you have to do for design and manufacturing, testing, verification, cost, and so on and so forth, you're going to see a lot of excitement, but not in products. That's my opinion.
Thank you. Any comments?
I'd like to hear your comments on that.
Just, I mean, I suppose, in a way, to agree with you, and this is, to my mind, additive manufacturing is just a tool. And when you look at products, how many products are just mechanical systems today? almost none. I mean, other than widgets like this, most products is a combination of hardware, electronics, and software. So additive manufacturing on its own is of, yeah, and service, absolutely. But, you know, additive manufacturing on its own is of no real use unless you put it in with all the rest of the systems you need to create, well, value. I mean, you know, the ultimate product is to not have the product, but just have the value of the product. Whether you ever achieve that, I don't know. So, yeah, I mean, I agree with you. It's electronics, it's software, it's service. Yeah.
Yes.
Links. So if I sit someone here who is now, I believe, totally in this, to reach the tipping point, I'm ready to invest. Should I invest in software? Should I invest in hardware?
Yes.
Or should I invest in an engineering bureau doing design? I mean, I have a feeling maybe I should invest in a law firm handling the patent protection. So is there any opinion? Where is the best way to spend the money?
I could comment as a company listed on the New York Stock Exchange. The only thing we haven't bought is a law firm yet. But seriously, we've bought the materials, compounding companies. We own the technology and the IP around the process. We have the factories that use the machines. And we're now vertically integrating into our customer base to help them innovate products that we have ownership in. And actually, I think the value is at the top of the supply chain, like every supply chain. You know, it's about the clever things that are made with 3D printing that have more value than the things that are not made by 3D printing. So I would invest in the applications. And certainly as a company, you know, we're pushing up the value chain because it's not in the base materials, it's not in the machines. The machines are becoming commoditized. You know, you can see that. It doesn't take a brain surgeon to see that the technology is becoming commoditized. So to me, it's smart applications. But again, it comes back to this, well, what is that smart application? There is no one killer app yet. And the day somebody comes out with it is the day that we hit that tipping point.
Phil, what about Hewlett-Packard coming out with what's supposedly a new technology, a new competing technology?
Hewlett-Packard's process is a combination of Beruk Shevchenetsky's inhibition sintering and Neil Hopkins high-speed sintering.
Right.
And they've have or have not licensed the IP from both parties. We can go into that.
Yeah. Do remember to walk up to the microphone. So do you think that we should invest?
My comment was what Phil thought about Hewlett-Packard coming out with competing technology next year, and that was his reply.
It's a new technology. They claim will be 25 times faster and better and make your breakfast at the same time. That'll, you know, they're claiming will revolutionize, but they're saying next year, so we'll see if it comes out.
Yes, please.
I just have a question on this national initiative. Who should be part of this national initiative? And maybe it would be a good idea to also have these regulatory aspects
yeah, definitely.
in this forum.
Yeah, I totally agree, because that is the main point. It should be inclusive, you know, to include all the different aspects and players in the additive manufacturing society in Sweden today, and also those that might not be a part of it today, but needs to be that there in the future. So we have done some tries before trying to find funding from Vinnova and so on, but we didn't really succeed, but we will continue.
Yes, maybe you should also have the government with you, because when we were briefing our government on the analysis we did on regulatory aspects, they did not even know who was responsible of 3D printing. And this is due to, as it's so horizontal, it's a lot of sectors which are involved. So maybe this should also be taken into account.
Yeah, and I would actually like to put that question forward to maybe you guys from the UK and listen to your experience from how it was done earlier back at your place.
Yeah, I mean, just as a backstory, I used to run a separate consultancy that was a pure additive manufacturing consultancy. We wrote the UK government original strategy on additive, and it was about engaging with the different government bodies right down to kind of societal issues. It was about that, engaging not just with the learning process, but with community. And then looking at the vertical industries and saying, well, who's going to exploit this? Because in the UK, I guess like you guys, you have Arcam, we have Renishaw. We have one technology vendor. You guys have a lot of materials capacity,
We have virtually no materials capacity. So we ended up with a very different strategy and framework that was based around exploitation at the top end of the supply chain, not feeding the bottom. So again, the national strategy has to align to what the strengths of the country are. And I think that's kind of where the UK is now, and we're revisiting this and saying, well, who should fund a strategy? So we've got what's called Innovate UK, which was the Technology Strategy Board, the Government Research Councils, EPSRC, so Engineering Research Council, or Social Sciences Research Council, Medical Research Council, and moving into computer science funding because of this realization that it crosses all boundaries.
I would just add one point. The America Makes model, it's a private-public partnership. The government of the United States put so much money in, and then some of the leading companies, including, I think, Stratasys as well, put monies into it. But they have kind of an intellectual property sharing arrangement to try to get over the barrier of IP, because IP can be a fence in terms of development as opposed to a help. So you join this private-public partnership. You contribute. If you contribute IP, you have to agree that you will license it under reasonable commercial terms to the other entities that are participating. So that's I think, a pretty successful model. Also, I know, and maybe Olaf knows the amounts, but China and Singapore, even little Singapore, has a huge government initiative.
I mean, even to put it in the context of Sweden, I'm using New Zealand example again. 3 months ago, they invested $23 million into the New Zealand Product Accelerator, a large part of which is based on additive manufacturing. Now, and I look at what Sweden's invested over the last 15 years, not a lot compared. And again, I'm using comparable. New Zealand's a smaller country than Sweden. Singapore, China, Germany, UK, big investment. Funding is what it's about, I suppose.
Yes, please.
Yeah, I just want to comment on the strategic agenda for Sweden and so on. So my name is Kenneth Bodin, and I run a company called Algorithmic Simulation. We develop simulation software, which is sometimes used for additive manufacturing as well. I think 3.5 years ago, I talked to Vinnova about a strategic agenda for additive manufacturing. And eventually we got some funding for doing that. So there's been actually quite a lot of work on a strategic agenda involving most of the research institutes, lots of companies, lots of universities, and so on. But it was placed in a big pile of 100 other agendas at Vinnova and forgotten about. I hope it's not forgotten about. But it really, it wasn't funded. There was even the whole call was closed, so there was no way of even approaching Vinnova for funding. So this is a problem. I think that we have 100 strategic agendas in Sweden, and there is no way to sort of do priorities in these.
Can I suggest a solution then? Go to your 100 largest manufacturing, service and retail companies and try to identify where 3D printing is on their strategic roadmaps. Because I suggest you'll find in a large percentage, it's in the top 5.
Oh, I totally agree, but the government has to sort of approach this discussion in a constructive way, because without investment, nothing will happen.
Yes, over there.
Hi, my name is Lyubov Belova. I'm professor at Royal Institute of Technology. One issue that I haven't heard sort of mentioned today, which I think is a very important aspect of the additive manufacturing, is in trying to reduce or even eliminate the waste of precious materials. And at least in electronics, is a very serious challenge, because if you're using platina or indium and other rare materials, then additive manufacturing is the only way of reducing the waste, because any lithography process or any other subtractive process results in enormous waste of such materials and patterning. And I think that this is one of the things, even from the society perspective, which is a very important aspect. And even if you're manufacturing, for example, implants, and you're reducing the use of titanium by doing this creative layer-by-layer patterning, I think it's a very big deal. Not just from the cost perspective, but just in saving the materials which are limited, the amount of which access is limited. Thank you.
Yes.
Yeah, I think the economic impact of additive manufacturing, if you view it in the context of what's happening in manufacturing overall, it's going to be mostly on enabling small and medium-sized companies to manufacture, and go beyond the prototype that they can do. At least that's what we observe in the US versus the individuals.
Please press the mic. Yeah. Press again.
So I pressed again. So I think the economic impact, to make short the statement, is going to be more for enabling small and medium-sized companies to manufacture beyond the prototype that they can do. At least that's what we believe in the US. And that's what the initiative of Obama was. It was not just 3D printed. It was design, manufacturing, and digitization of the manufacturing process. And that's why we created the regional centers to help this. And not so much on the individual sitting down and printing by themselves. That, in my opinion, is a bit of a toy situation, because you're not going to allow individuals in any government to produce products that they will have any safety requirements like that. Okay.
Just to comment on it, I mean, today we've mostly been talking about making products through additive manufacturing directly, but one thing we haven't really touched on is, for example, tooling. And a lot of the big companies now are starting to look, well, maybe we're not going to manufacture our parts directly through additive manufacturing, but we can manufacture tooling through additive manufacturing. Also, there's a big effort now in Sweden with quite a few of the big companies involved in looking at spare parts. So additive manufacturing, I mean, Tetra Pak has 800,000 unique spare parts, warehouses full of them. They have to keep them for 20 years, and they know that over 80% of those are going to be scrapped. They'll never be used, but they have to keep them. So interest in those areas may be ways of looking beyond just direct part production, maybe.
The other thing is, you know, it's not. You're right about small and medium businesses, making them capable and productive, but don't dismiss big businesses using this to try to act like small businesses. Because having been acquired by a big business, I can tell you small businesses are far more responsive to change, and we're seeing big businesses adopt this as a way of being responsive.
Mike, please.
I think, as you said yourself, big businesses have already adopted it, and it's very high in their priority. I don't worry that they are not going to go into all of the big companies I know. They already have plans and they're already exercising, and you mentioned some of them. But the medium and small-sized companies is where an initiative may help. Okay, and I repeat, this country has extremely good ICT, extremely good software tools. Okay, we brought together your major 5 universities: Uppsala, Linköping, KTH, Chalmers, and Lund in this context. But now we want to take that and actually get it into use in manufacturing, and that's where we need some initiatives.
Thank you. Yes, please.
Oh,
sorry.
Can I just add on that one as well? I think the greatness of this country is also that this is the country that is very good at productization and commodization. So we have brands like IKEA and H&M and so on. So I think it's really the H&M or the IKEA level. So the Swedes, if anyone, can actually make it into what you call the killer app. What's in it for the end users or the customers?
Please.
Oh, finally. I'm trying a couple of times here. Okay, a couple of points here. First of all, we should not mistake 3D, or what you call it, I prefer additive manufacturing, as one technology. It's a multitude of technologies. And the tipping point, well, it's a little bit, it's not defined, as I said earlier. Really, what we are reaching a number of nucleation points where the technology can actually enable an application to become better. And the real value of this technology will probably not be in sales of materials and products, but really how they are used, how they are improved. If you make tooling that sort of can double the productivity, then that is something. Or if you can save weight in an airplane to save a lot of fuel, that's something. That's the real huge value creation. I work for Sandvik now, and Sandvik has done a corporate research initiative, and that's why I work for it. It's a major investment. We're building a research teams, and it's probably the biggest and most competent research team in additive manufacturing in Sweden. That's something we talk about, this national initiative, research initiative. Just about any college in Sweden now, I want to do 3D printing. And just about any person who has surfed 5 minutes on the internet can explain themselves to be an expert. And that's a problem, because Sweden is 10 years behind, and is about to turn this area into amateur's night. And that can cost a lot of money, because I don't think we can afford to waste the time and money to have everybody start to learn, everybody in every place start to learn from zero.
Thank you. Some final comments on that.
I think it's been great food for thought, hasn't it?
Yes. Then I would like to thank the speakers panel and the audience. Thank you so much. I think we all have had a very enlightening and interesting afternoon, and we learned a lot about 3D printing and additive manufacturing, both the huge potential and all the challenges. And we might not be really clear of where we are right now, and hopefully the future will tell. Thank you so much. Then I will leave to Björn Nilsson to give some final remarks.
Okay, thank you. For the next hour, I'd like to give my final... We have a rule in this academy that the president of the academy always gets the last word. So I'm the president, Björn Nilsson. I must say I've had lots of fun, a lot of food for thoughts, and I'd like to give you just a few comments before we are all totally fatigued and we should break up. We learned, of course, that maybe we need to discriminate between additive manufacturing and 3D printing. That was very useful, but that led into, I think, where people start to smile, where we see many new applications and many applications that we may surf on internet to learn about this technology, because when you see what you can do with it, it's when you really get inspired. And I got a lot, very inspired, of course, to reduce materials in aerospace parts and in complex engineering parts in general, and of course for the customization as an application area where, of course, the body fit part, we know both for hip implants and dental implants and hearing aids, but also when it comes to customization where you want to customize your jewelry and your clothes or anything. I found it interesting that the company who made this customization jewelry software was called Nervous System. Maybe that's an implication of this area in a sense. We also learned to discriminate between the home market with 3D printings, even that can be commercially organized into communities, 3D hubs, but also the commercial production. From Bill, we learned that the legal implications are enormous, they're vast, and this is not simple, so don't get into this and believe. There are liability challenges and copyright challenges, and how will patent law deal with this? And it's, I think, as we heard, at least patent lawyers will make a fortune, and that's where we should invest, wasn't it? Also that there are 6,000 patents just in the 3D printing space, which is also, of course, an interesting part. We also learned from Olaf that, which was a good start, I think, that 3D printing or additive manufacturing would never replace traditional manufacturing. And I don't know, maybe it will if we speed up very much, even though injection molding is hard to beat in time because it's a sub-fraction of a second to manufacture. Quite complex and also quite big, big parts. I found it interesting in Ian's talk, the quotation that 3D printing will change the world from Harvard Review. And I also want to comment on what Anna and Lars-Erik brought in. Anna pointed out what's in it for me, that's an important part to answer, and also what also was part of the panel from Lars-Erik, that we need some kind of national initiative here to catch up in Sweden, and I find that interesting, even though there are companies like Höganäs and others who have, at least in part of that, brought in 3D printing. The question of this meeting, are we beyond the tipping point, was not answered entirely. We heard first we are beyond the tipping point, but then we're not, because we haven't really designed anything that's dependent on the 3D printing technology or comes out of that. What I found interesting at the tipping point can be positive or negative. The tipping point for steam engine was the combustion engine. The tipping point could actually go downhill. I found it interesting that we all regard that question to be only positive. That's a good spirit, maybe, of this meeting. What was only touched upon a little bit was, of course, the field where I'm mainly in the life science field, where I know that in tissue engineering, this is currently now really a breakthrough technology. Currently mainly experimental to see could you do a new liver, a new kidney, and there are lots of good results. So, so maybe in the future, kids will ask their mother or their father, not ask the question, when was I born, but instead, when was I printed? Maybe we should. Maybe we shouldn't hope for that, but or you come into the hospital and say, I think I have some problems. Could you 3D print a new brain for me? And can I get it this afternoon because I have a meeting? Yeah. Nevertheless, it's been very inspiring. I think that's what meetings are for. That's what we came here for, and I'm very inspired. I'm sure in a few years' time, so many things have happened, so we wouldn't recognize any of these slides because there's so much that has happened. And I'm thinking about the question, if we were 20 years into the future, what would we have wished we had clearly seen today, which we don't see, because often your own imagination sets the limit. And I'm sure there are such things that we would say later, we should have seen that much, much earlier, that these things came. And maybe in a meeting like this, we get at least closer to such breakthroughs in our own creativity. Very finally, I'd like to thank everyone. I'd like to thank the speakers. I'd like to thank our moderator, Ann-Louise, and also Johan Weigelt, who's been very instrumental in setting this up, and the section 4 of our academy, who's been behind the scenes to section 1, yes. And of course, all of you coming here. So thank you. I think we should give all ourselves a big hand. So, thank you.